Our cosmos is a place of absolute brutality. The outer space is filled with worlds that resemble actual versions of hell. What we are discovering out there is a terrifying gallery of planetary beasts. There are incredibly scorched planets that are baking at thousands of degrees. There are deep frozen planets that are far too icy for anything to survive. There are completely barren worlds being blasted by destructive, deadly cosmic radiation. We are even finding places where actual stones and liquid rocks rain down from the skies. Scientists have located hundreds upon hundreds of these bizarre bodies in space, and they are completely insane. We scan the deep night sky hoping to locate a planet that resembles our home, but instead we keep finding environments where living things could never endure. How can the outer space be this incredibly bizarre? Is our planet Earth completely unique? Are we truly the single oasis of life in the entire cosmos? Or are there other environments just like our homeworld out there, waiting in the darkness for us to finally spot them? Take a moment to stare out into the deep void of space. There are billions of distinct galaxies scattered across the dark, and trillions upon trillions of shining stars. This leaves us with one single, incredibly deep question to answer. Is there someone else alive out there in the dark? We desperately want to locate another version of Earth. Is there a tiny pale blue speck orbiting a distant sun somewhere out there in the vastness of the galaxy? The great scientific race is currently underway to find distant worlds that might be capable of supporting living organisms. We are essentially scanning the deep void for a reflection of our own existence out there in the stars. We are actively hunting for our own cosmic paradise. Up to this point, astronomers have already located more than 700 distinct planets resting outside our own solar system. And yet, despite our high hopes, these distant exoplanets look absolutely nothing like our home. Man, were our initial assumptions completely mistaken. When we look at all of these alien solar systems that we are uncovering in deep space, we are finding out that they do not resemble our own local solar system in any way. We are the true oddballs of the cosmos. We are the strange freaks of the universe. These distant places are genuine nightmare planets. And the truth is, the entire universe is completely packed with them. Scientists are constantly uncovering completely different variations of absolute hell. They are seeing all the unique ways that a planet can form incorrectly and turn dangerous. So that is exactly where we stand as a species right now. We are actively searching for paradise, but we keep running directly into hellish landscapes. These are extreme environments where no known life form could ever manage to survive. Could it be possible that human beings are truly completely alone in the dark? Are we just a bizarre cosmic accident in a massive universe that is fundamentally hostile to the existence of life? We might actually have the definitive answer to that question very soon. At this moment, we have successfully located hundreds of alien exoplanets across outer space, and we are finding them at an incredible speed of more than one new exoplanet every single week. Within just a few more years, that number will easily grow into thousands of discovered worlds. And when it is all said and done, there could literally be millions or even billions of these alien bodies waiting out there for our telescopes to find them. But how could every single one of them be a terrifying planet from hell? Our journey to find the true answers to this mystery begins right here, located 63 light years away from our home planet Earth. Out at this specific distance, astronomers have uncovered a massive planet. This specific world is significantly larger than even the giant Jupiter in our own system, and it suffers from a truly massive, life-threatening problem. Its path around its parent star is incredibly close and tight. It is situated much closer to its host star than the planet Mercury is to our own Sun, and it sits 30 times closer to its heat source than the Earth does to the Sun. The ultimate outcome of this setup is a completely superheated, baking environment of pure hell. But there is another terrifying reason why absolutely nothing could ever live on this world. And that reason is the presence of unbelievably violent, ferocious planetary wind. The entire surface of this planet is constantly hammered by a chaotic, never-ending storm system. We are completely unable to observe these fast-moving winds using our standard optical telescopes, but scientists know for an absolute fact that this extreme superstorm is raging out there. We can prove its existence because of a very special piece of space equipment. This is NASA's famous Spitzer Space Telescope. The Spitzer instrument possesses the incredible capability to observe things in space that human eyes can never see. It does not gather images using the standard visible light spectrum. Instead, it captures the universe by looking through the specialized infrared spectrum. This is a specific segment of the light spectrum that our human eyes are completely blind to. Infrared light is essentially the measurement of pure heat radiation. One major benefit of analysing the vast universe through the lens of infrared technology is that it provides astronomers with a unique chance to detect the faint light radiating directly from planets that are spinning around distant stars. When a scientist attempts to capture the light of a small planet resting right next to the massive light of a giant star, the parent star is hundreds of thousands of times more blinding than the companion planet. This overwhelming brightness makes the planet appear completely faint and invisible to normal equipment. But if we shift our observations deeper into the infrared portion of the light spectrum, the internal heat generated by the planet itself causes the world to visibly glow in the dark. Much like our own body, heat glows on thermal cameras. Because of this heat signature, the planet suddenly becomes completely visible and highly measurable to our scientific instruments. The Spitzer telescope gives humanity something entirely unprecedented. It has allowed us to map out the very first alien weather chart of a planet situated entirely outside our own solar system. This basic-looking graphic represents an incredible technological achievement for our species. The distinct variations in colour on the chart show the precise temperature differences across the world. But this heat map also provides definitive proof that the planet is whipped by truly hellish wind systems. The reason we know this is because the planetary hotspot is not located in the exact position where it logically should be. One side of this specific planet is gravitationally locked to permanently face its parent star at all times, which means the exact centre of that day side should be the absolute hottest location on the entire world. But it simply isn't. Something is actively shifting the planet's primary hotspot far over to the side, and causing that shift requires an absolutely staggering amount of atmospheric force. Only a continuous, non-stop hurricane blowing at a ridiculous 6,000 miles per hour could generate that level of raw power. That is 20 times more violent than the most destructive hurricane winds ever measured on the surface of the Earth. It is equal to 8 times the speed of sound. A tiny structural shift on a colourful weather map serves as undeniable proof of supersonic storms constantly tearing across an alien world. It is truly an authentic planet straight from hell. Humanity is currently spotting these brand new worlds at an absolutely mind-boggling pace, maintaining a steady average of one new planet discovery every week. Every single location we find has the potential to be a beautiful Earth-like paradise. But the more we utilise our technology to investigate them, the more hellish and hostile environments we seem to uncover. In fact, some of these worlds are so shockingly hot that they go far beyond being merely unlivable for organisms. They are so extreme that according to our old theories, they should not even exist in the first place. This specific gas giant world, which is roughly the size of Jupiter, is located 256 light-years away from our home. When viewed through the specialised infrared spectrum, it glows so intensely that it resembles an actual star. it shines thousands of times brighter than Venus, which is the most severely scorched planet inside our own local system. The temperature on this giant world is a blistering 3,700 degrees. It should be virtually impossible for a planetary body to ever reach a temperature this extreme. The world's insanely hellish temperature provides scientists with a major hint regarding what it actually looks like to the human eye. Only a material body that is completely, absolutely pitch black could absorb a sufficient amount of incoming light from its parent star to reach such devastatingly hot temperatures. If you were approaching this world from its dark night side, away from the star's illumination, you would be confronted by nothing but a massive wall of pure blackness. There would be almost zero radiation and zero visible light reflecting off it. It would truly look as though the stars in the background were simply vanishing from a specific circular patch of the night sky, in the exact same way that a dark asphalt road absorbs intense sunlight and gets incredibly hot on a bright summer afternoon. This pitch-black planet absorbs radiation and roasts continuously right next to its sun. Scientists still do not fully comprehend the unique atmospheric chemistry of this world. There is absolutely no substance found on Earth that possesses the ability to soak up that much raw light without reflecting any of it. The only visible coloration on the entire planet originates from a massively overheated storm spot. As a traveller flies around to the illuminated day side, the environment would start to glow a vibrant fiery red from the sheer heat. You would see a massive swirling hurricane system that is entirely red and radiating thermal light. What an incredibly hellish destination. Deep inside this atmosphere, massive clouds of vaporized titanium oxide swirl aggressively around a solid planetary core that is 100 times more massive than the Earth itself. It is a place of visible darkness. It is yet another terrifying world straight from hell. However, some of the planets we are finding are even more massive, presenting scientists with seemingly impossible cosmic riddles to solve. Here is a major scientific puzzle for you. Every standard astronomy book explicitly states that massive gas giants, like our own Jupiter, can only form way out in the distant reaches of space, where the environment is incredibly cold. So if that rule is absolute, why are we finding a Jupiter-sized gas giant sitting deep inside the system, way closer to its star than the orbit of Mercury is to our Sun? Gas giant planets require the freezing temperatures of deep outer space to successfully accumulate their massive atmospheres. Finding a giant ball of gas orbiting this incredibly close to its parent Sun means that these planetary monsters possess the terrifying ability to move across space. This specific world is known as WASP-12b, and it represents a truly scorching, horrifying vision of cosmic hell. It is positioned so staggeringly close to its parent star that its entire year, its full orbital path, takes just one single Earth day to complete. This world experiences such severe heat that it registers at over 4,000 degrees Fahrenheit. This is just completely mind-bogglingly hot. WASP-12b stands as one of the absolute hottest planetary bodies ever detected in our entire galaxy. Human scientists have never encountered an environment quite like this anywhere before. This place undoubtedly ranks as one of the most fundamentally violent and destructive settings in the known universe. WASP-12b is situated a mere 2 million miles away from the surface of its roaring star. The searing, relentless heat causes its outer atmosphere to bloat up dramatically, giving the outer layers of the planet the actual physical density of common styrofoam. If you could somehow find a bathtub large enough to hold it, this giant world would actually float on top of the water. Scientists believe that the planet is so dangerously close to its star that the extreme gravity and tidal pulling forces actually warp the entire world into an elongated egg shape. It is not even a round sphere anymore. It has been pulled into an oblong object. Thousands of miles beneath this intensely puffed up outer atmosphere lies a massive, solid internal core. This core is incredibly rich in carbon elements, and the internal pressures inside the planet are absolutely extreme. Because of these conditions, there could be massive mountains made entirely of solid diamond and graphite, surrounded by vast churning oceans of hot liquid tar. But WASP-12b is running out of time and will not exist for very much longer. It orbits its sun at such a dangerously short distance that the star's immense gravity is literally ripping the planet apart piece by piece, tearing away nearly 190 quadrillion tons of atmospheric gas every single year. Just 10 million years from now, WASP-12b will be completely consumed and will vanish from the universe forever. The big question that scientists are trying to solve is, how did this massive world manage to get so incredibly close to its star in the first place? What you are looking at here is the chaotic birth of a brand new solar system. In the exact centre, a newborn star is waking up. Churning all around this young star is a massive, flat disk composed of microscopic particles of cosmic dust. These tiny grains are actually planets in the very early stages of making. The dust particles are constantly bumping into one another, and every single time they collide, they stick together and merge into a larger piece. Because of this, they gradually expand in size, growing in a very similar fashion to the common dust bunnies that accumulate under your bed. A system has about 100,000 years, or 1,000,000 years, to let these particles combine into a massive cosmic dust bunny, and they just keep getting larger and larger and larger over time. Trillions of miles away from the heat of the central star, the environment becomes cold enough for solid ice to form. This expanding ice acts like a magnet, picking up stray dust particles and absorbing surrounding gases. These gaseous clumps continue to grow larger and heavier over the course of millions of years. Eventually, through this slow process, they transform into massive gas giants. In our own local solar system, the large gas giant planets like Jupiter, Saturn, Neptune, and Uranus all formed through this exact environmental process, remaining in the cold, distant outer orbits, where we still observe them travelling today. So, how did a world like WASP-12b wind up sitting in such a searing, dangerously close position to its parent sun? The ultimate answer to this riddle is the force of raw gravity. This specific planet is absolutely enormous, possessing 40% more physical mass than our own giant Jupiter. Its massive gravitational pull creates severe disruptions in the surrounding dust disk from which it was born, generating intense structural turbulence. Because of its weight, the planet sends massive ripples through the material of the disk, creating dense gravitational waves. You can easily visualize these features as being just like large waves moving across the surface of an ocean. This transformation turns the gas giant into a literal galactic surfer. Over the course of hundreds of thousands of years, the heavy planet rides these internal material waves inward, spiraling closer and closer toward the central star. As the planet migrates nearer to the sun, it begins to experience the star's intense thermal radiation more and more powerfully, and its temperature skyrockets. It essentially surfs millions of miles away from the freezing outer edges of the stellar system, moving directly into the tight, scorching orbital path that we observe today. An environment that started as an ice-cold world is transformed into a terrifying planet from hell. Prior to these findings, no astronomer had any real inkling that a planet could form 1 billion miles away from a star and then somehow migrate all the way inside. That discovery is absolutely mind-boggling. But this orbital migration is truly the only logical explanation for how these giant worlds managed to get so incredibly close to their parent stars in the first place. WASP 12b is incredibly bizarre, but it is certainly not a unique case in the cosmos. We have discovered a large number of these super hot, super close gas giants scattered across the universe. Astronomers refer to this specific class of planets as hot Jupiters. They are worlds that are continuously battered by supersonic hurricane winds, covered in surfaces blacker than the darkest night, and radiating temperatures hotter than hell itself. But all of these hot Jupiters share one definitive characteristic in common. There is absolutely no possibility of life existing on them. So, these specific worlds are about as radically different from our home planet Earth as you could possibly imagine in your wildest dreams. In fact, our instruments have now located well over 100 of these specific objects, rendering them so common across the universe that a profound question naturally emerges for scientists. Which type of solar system is the actual weirdo here? Is it their chaotic systems, or is it our own orderly system? This planetary roller coaster ride brings massive physical consequences to the rest of the solar system. As they spiral aggressively inward toward their stars, these hot Jupiters create absolute gravitational chaos for any smaller worlds in their path. Their migration gives birth to an entirely new, terrifying category of planets from hell. These are the orphan worlds, planets that have been violently cast away from their parent stars and flung out into the freezing, empty void of interstellar space. We are taught that planets must always orbit around stars. Between the individual stars in our galaxy lies a massive, seemingly empty sea of absolute darkness. We have always traditionally conceptualized outer space as being completely empty of objects. In fact, that emptiness is considered its absolute defining characteristic, which is the exact reason why we simply call it space. But when modern planet hunters shifted their focus away from examining bright stars and started pointing their instruments deep into the empty blackness of space, they stumbled upon an absolutely amazing discovery. Out of the deep, pitch-black void situated between the stars, actual planets suddenly began to materialize on our sensors. First, scientists spotted one dark, isolated gas giant drifting alone, and then they quickly located several more. Eventually, a group of 10 dark, starless planets emerged from the deep shadows of outer space. I frequently wonder what it would actually feel like to stand on the surface of one of these rogue planets, drifting in the void between distant stars. The night sky on such a world would be completely, perfectly black, yet it would be intensely packed with brilliant stars. It would probably look absolutely beautiful. But if you were stranded on one of these worlds, you would find yourself trapped in an environment of perpetual, never-ending night. There would be no such thing as a sunrise or a sunset. You would never feel the comforting warmth of a nearby sun. These isolated planets originally formed around a parent star just like any other world, but they now spend eternity roaming the frozen darkness of interstellar space. Their historical journey to this dark void was incredibly violent. Every single one of them was forcefully kicked out of its original home orbit by the overwhelming gravitational pull of a migrating hot Jupiter. A Jupiter-sized planet functions as the absolute 800-pound gorilla of a solar system. Where does an 800-pound gorilla sit? It sits absolutely anywhere it wants to. These hot Jupiters are literal system killers. As they surf their way inward toward their parent star, their massive gravity severely disrupts the orbital balance of the entire solar system, physically launching smaller neighbouring planets completely off their safe orbital paths. It violently flings out into the freezing void of space any small planet that gets in its way. So any world unfortunate enough to be orbiting close to its mother star would be instantly cast out into interstellar space during a close encounter with a passing Jupiter-sized monster, these exiled planets will never again experience the thermal heat or witness the brilliant light of a parent sun. All of the rogue planets that our technology has successfully located up to this point happen to be massive gas giants, but it is highly probable that there are also much smaller rocky rogue worlds drifting out there as well. There could easily be starless worlds that were once very similar to our own Earth. The massive Jupiter-like rogue planets are simply much larger and far easier for our current technology to spot in the dark. But there is absolutely no scientific reason to assume that smaller, orphaned rocky planets do not exist in equal numbers. Perhaps as a massive Jupiter-like planet migrates inward toward its star, it plays a chaotic game of cosmic ping-pong with the smaller internal worlds. During this chaos, an ordinary planet like Earth could easily get kicked completely out of the system. If that happened, you would be left with a freezing, completely frozen little world streaking blindly through the void between the stars, utterly dark and profoundly lonely. These worlds are the tragic casualties of a brutal, violent gravitational warfare. They are frozen, orphaned twins of Earth. There may literally be hundreds of billions, with a B of these isolated planets roaming blindly through our galaxy. Now, it is important to remember that there are only a couple of 100 billion actual stars inside the entire Milky Way galaxy. So what that data means is that these drifting rogue planets may actually outnumber the stars themselves. At this current moment, human scientists are discovering an average of at least one new exoplanet every single week. As our technology and telescopes continue to advance, we will gradually become capable of spotting smaller and smaller planets orbiting distant stars. We will finally see worlds that possess a solid rocky surface just like our own home. But the very first rocky worlds we have successfully located look absolutely nothing like Earth. These solid planets have been to hell and back. Up to this point, our instruments have successfully located hundreds of these distant alien worlds. And now, for the very first time in human history, our astronomers are finally discovering small, compact planets made entirely of solid rock, which match the basic physical composition of our own Earth. Planetary bodies that fall into this specific size category are considered by scientists to be highly potential environments for the development of living organisms. But instead of finding lush, peaceful havens, our telescopes continue to uncover more terrifying variations of absolute hell. They are incredibly weird, profoundly nightmarish, and completely uninhabitable for any known form of life. This specific rocky world is known to astronomers as Corot 7b, and it represents a place characterized by truly violent environmental extremes. It is essentially two completely different versions of hell wrapped up into one single planet. This solid world is situated so staggeringly close to its parent sun that the star appears absolutely enormous, looming 360 times larger in the alien sky than our own sun appears from the surface of the Earth. On the surface of Corot 7b, the very first version of hell you encounter is unimaginably and overwhelmingly hot. The entire landscape on this side functions as a literal cosmic furnace, constantly baking at a devastating 4,700 degrees. This extreme heat causes the surface lava to actively boil, which completely vaporizes the rocky ground and turns it into an atmosphere made entirely of gaseous stone. Whenever a slightly cooler atmospheric front moves across the region, tiny pebbles begin to condense out of the air, causing actual rocks to rain down from the sky. If that specific scenario does not match the classic historical description of absolute hell, then I honestly do not know what does. But that terrifying landscape only accounts for exactly half of the planet's story. The intensely heated day side of this world is completely locked by gravity, meaning it permanently faces its parent star at all times without ever rotating away. Just beyond the edge of this burning furnace lies the planetary twilight zone. The environment in this specific narrow strip is relatively temperate. It is just cool enough to allow the massive oceans of boiling lava to cool down and freeze into solid, stable rock. However, this pleasant and comfortable living zone is incredibly narrow. If you travel just a little bit further past this boundary, you instantly descend into a completely different second version of absolute hell. This is the permanent dark side of the planet. It encompasses the entire half of the world that is doomed to never see the light of its sun, trapped in eternal blackness and exposed to savage, unrelenting cold. The environmental temperature on this dark side plummets to hundreds of degrees below zero. So you are left with a world where one side is completely on fire, while the other side is entirely frozen solid. You are essentially dealing with fire or ice taken to the absolute structural maximum, combining some of the coldest environments in the entire universe with some of the hottest locations in the cosmos. A traveller could not possibly dream of a worse place to accidentally wind up stranded. But this rocky planet was not always characterised by this type of extreme violence. If we turn back the cosmic clock by 1.5 billion years into the past, we can witness the historical formation of Corot 7b. During this early era, it is not a solid rocky body at all. It actually starts its life as a massive gas giant. It is roughly 100 times larger than the Earth, and it begins to migrate aggressively inward from the outer system toward its parent star. As it closes the distance and parks right next to the Sun, the star acts as a literal cosmic blowtorch, blasting the gas right off the planet. The giant gaseous shell is completely blasted off into the void of space, which gradually uncovers the world's dense, rocky internal core. Corot 7b is essentially the skeletal remains of a vanished hot Jupiter. Its fierce parent star has systematically reduced this once massive gas giant down to nothing but a charred rocky cinder. It is incredibly difficult for the human mind to conceptualize planets that are more extreme than the landscape of Corot 7b. Yet, the truth is that even more terrifying worlds do exist out there in the dark. There are solid rocky worlds that are continuously machine-gunned by highly destructive, deadly cosmic rays. This specific object is a pulsar, located a staggering 7,000 trillion miles away from our home planet Earth. It functions in space as a type of high-energy cosmic lighthouse. This unbelievably compact world is a mere 10 miles across, yet it continuously fires an intense, focused beam of deadly radiation through the void of space as regularly and precisely as an atomic clock. To help understand its extreme nature, a single cubic centimetre of material from this object, a piece no larger than a standard keyboard key, actually contains about as much physical mass as Mount Everest. Imagine squeezing the entire bulk of Mount Everest down into the size of a tiny sugar cube. The entire star, which measures only about 10 miles from side to side, is composed completely of that dense material. This makes it one of the absolute most hostile and deadly environments in the entire known universe. Anything that gets anywhere near this object is instantly hammered by intense gravitational forces and overwhelming magnetism. No astronomer ever expected to locate actual planets orbiting a dead star like this, but this specific pulsar happens to possess 3 of them. They are small, rocky, and very close to the size of our own Earth. In fact, they were the very first exoplanets ever officially discovered by humanity, and they represent the absolute last place in the cosmos where you would ever expect to find life. This dead star generates a tremendous, crushing magnetic field, and it is constantly blasting out intense X-rays into the surrounding space. Because of this setup, these poor companion planets are just getting cooked to death by lethal radiation. The standard descriptive word Earth-like is something that I do not think could be applied to these miserable worlds at all. The intense X-ray beam repeatedly strafes across the planets over and over again as the pulsar spins, firing energy that is 1,000,000 times more deadly than the medical X-rays used in human hospitals, which slowly strips their entire physical surfaces away into the void. These are completely sterile, dead worlds. Every scientist readily admits that there is absolutely zero chance for the existence of life, at least as we currently understand it, on any of the planets that orbit this pulsar. The relentless radiation simply cooks these pulsar planets to death. However, the opposite variation of cosmic hell is not any better for living organisms. There are deep frozen worlds out there that are far too cold for any life to ever take root. Located in the distant constellation of Scorpius, roughly 20,000 light-years away from our home, sits a red dwarf star. Red dwarf stars are inherently tiny bodies and are relatively cool compared to our Sun, and this specific planet is positioned much too far away from its star to ever feel what little thermal heat is being generated. It sits so incredibly distant from its Sun that a single orbital loop takes 10 full Earth years to complete. It currently holds the record as the absolute coldest planet we have ever successfully located in the known universe. The surface of this freezing world is a frigid 370 degrees below zero. This is an environment composed entirely of solid ice. Chemical compounds like methane, ammonia and nitrogen exist as standard gases on Earth. But in this severe environment, they freeze solid to form a highly toxic frozen frost across the landscape. Massive glaciers, deep frozen canyons, and towering cliffs of solid chemical ice represent the only physical terrain that exists here. In this location, hell has quite literally frozen completely over. Once again, our grand scientific search for an elusive twin of the Earth reaches another frustrating dead end. Perhaps human beings are truly completely alone in the vast darkness, or could it be that our very first tantalizing glimpses of a distant alien world, one that is potentially perfect for the development of life, is about to change everything we think we know? Our planet Earth remains the only truly habitable world inside our own local solar system. But inside a massive galaxy composed of hundreds of billions of stars, can we honestly be completely alone in the dark? That is the exact question that modern planet hunters are desperately trying to answer. In my personal opinion, the entire underlying purpose of discovering these distant exoplanets is to finally establish our true, definitive place within the wider universe. Who are we as a species? Where do we actually belong in the grand cosmic scheme of things? Are there other planets out there in the dark that can harbour life just like our own? That is precisely where NASA's Kepler Space Telescope comes into play. The Kepler instrument allows scientists to precisely calculate exactly how far a planet is positioned from its parent star. Mapping that specific distance is absolutely critical in figuring out whether or not a world could ever sustain living organisms. Life on Earth is only possible because we happen to sit at the absolute perfect distance from our Sun. We are located not too hot and not too cold, but just right to allow liquid water to form oceans, rivers, lakes, rain, and support life. You know, mainstream journalists always tell you to follow the money, but astronomers prefer to say, follow the water. We say this because liquid water acts as the universal solvent that can dissolve most chemicals, and that specific liquid environment is exactly where DNA originally managed to get off the ground on our planet. And wherever you find liquid water pooling, there is a real possibility that life could be thriving. Therefore, we are actively searching for planets that are not positioned too close to their parent star, where the intense heat would cause all the water to instantly boil away into space. At the same time, we are looking for worlds that are not located too far away from their star, where all the water would be completely tied up in a frozen, icy form. We are hunting for that specific, elusive Goldilocks zone, where the environmental temperatures are just right to allow liquid water to stably pool on the planetary surface. Once the Kepler telescope successfully identifies a brand new planet candidate, astronomers immediately check the math to see whether or not it lies within the habitable zone of its parent star. Up to this specific point in time, Kepler has not located a single officially confirmed identical twin of the Earth. However, it has successfully identified more than 2,000 planetary possibilities waiting to be verified. And it is this sheer, overwhelming abundance of planets that gives modern scientists so much genuine hope. The most important thing for us to remember is that even though we keep finding all of these terrible hostile planets that are completely unlivable, we are finding an absolute lot of them. We are uncovering hundreds and thousands of these worlds. And what that data is clearly telling us is that planets are actually very easy for the universe to make. That structural reality means that even incredibly rare things are probably out there existing in massive numbers. Even if a world like Earth is a rare, precious jewel inside our galaxy, there may still be dozens or hundreds of them scattered across the stars. The Kepler mission has officially opened our eyes to a universe that is completely full of planets. Because of this data, we can now make an educated guess regarding exactly how many worlds might exist inside our own home galaxy. The number is a staggering 50 billion. There are 50 billion worlds out there just waiting to be discovered by our instruments. And scientists estimate that roughly 1% of them could be sitting directly within the Goldilocks zone of their respective stars. That equates to 500 million planets, each possessing a real mathematical chance of harbouring life right here on our own cosmic doorstep. We have not successfully located a perfect match just yet, but our instruments are getting closer every single day. Consider the star system known as Gliese 581, which is a small red dwarf star located 20 light years away from the Earth. Gliese 581 is a tiny little star. If you imagine our own sun as having the raw brightness of a standard 100-watt light bulb, then Gliese 581 would look like a tiny little Christmas tree light, a minuscule fairy light that is very, very small. This lower energy output shifts the system's life zone significantly inward. Now, if a planet wants to be warm enough to support liquid water, it needs to snuggle up right next to the star. This specific star is orbited by 4 distinct planets. 3 of them are positioned way too close to the heat source, causing any liquid water to boil away. But the 4th planet is radically different from the rest. It is a solid rocky world that is roughly twice the physical size of the Earth. And it sits right on the comfortable edge of the system's Goldilocks zone. In theory, if this planet possesses a sufficiently thick atmosphere made of carbon dioxide, it could trap enough heat through the greenhouse effect to maintain atmospheric clouds, liquid rain, and vast oceans. It would certainly be a very strange place for humans to live, featuring twice the gravity of Earth and being constantly bathed in a permanent red twilight. But right now, this weird world stands as the absolute closest thing we have to a habitable planet like our own. It represents a highly promising start to our journey. When we finally establish for a historical fact that there is a planet just like Earth orbiting a star up there, that discovery is going to fundamentally change how humanity looks at the night sky and how people perceive our true place in the universe. So that is going to be an incredibly profound moment, not just for me personally, but for human civilization in general. Our ultimate goal remains to locate another Earth. But along that path of discovery, we are going to encounter more unbelievable things than we could have ever possibly imagined. And that is the specific aspect of this science that I love the absolute most. We simply do not know what crazy discoveries are going to be waiting around the very next corner as we search for more planets. I cannot even begin to imagine what we will find next. What appears to be an ordinary regular field of stars in the night sky actually plays host to one of the most astonishing and extraordinary stellar entities in our entire galaxy, situated roughly 8.7 light years away from our home planet Earth. This specific cosmic object is officially known to astronomers as UV Ceti. This highly mysterious and unpredictable body possesses the terrifying capability to increase its natural brightness by 5 full times in less than a single minute of time. Any companion planet that happens to be circling around this unstable star would be violently blasted by extreme sudden heat, which would quickly melt away any frozen surfaces that had formed on the world. Then, just a few seconds later, the volatile sun dims down drastically. As a result of this sudden drop in light, the planet instantly retreats back into an icy pitch-black darkness. But the star UV Ceti is about to take things way further than a simple variation in standard brightness. The unstable body begins to grow intensely bright once again, but during this specific event, the amplification of light simply does not stop. It transforms rapidly into a completely runaway, out-of-control stellar inferno. In a mere span of 20 seconds, the star becomes 75 times brighter than its normal baseline state, releasing a massive wave of energy. This means that UV Ceti has just unleashed a colossal mega flare across the system. This event represents a truly immense catastrophic explosion of energy occurring directly on the star's outer surface. If our own local sun were to ever fire off a massive mega flare resembling this specific explosion, the entire human race would be completely turned to toast. If you were physically standing on the surface of the Earth and our sun were to suddenly get 75 times brighter, even if that extreme amplification only lasted for a minute or two, it would honestly and probably be the absolute last thing your eyes would ever see. The overall environmental temperature across the entire planet Earth would skyrocket instantly. We would witness massive global forest fires breaking out everywhere at once. It would just basically cook and incinerate every single living thing on the planet. Fortunately for us, our planet Earth is situated a very long physical distance away from the volatile UV Ceti. Human civilization is entirely safe from the dangerous outbursts of that specific distant star. But the reality of astronomy is that the more stars we isolate and study, the more of these extreme flares we seem to find scattered across space. They are constantly firing off in every conceivable direction across the cosmos, and sometimes they are pointed directly at us. The closer a volatile star is positioned to the Earth, the greater the potential danger becomes for our world. And one specific star happens to be positioned way closer to us than all of the other stars in the universe. When we look up at it, our own local sun appears to be completely stable, quiet and calm. But behind that familiar bright glare, the sun is actually a terrifying planetary monster. Specialized solar observatories are constantly capturing the true deep violence of this object. Massive solar flares are continuously erupting across its entire active surface. These represent gigantic explosions occurring on an almost unimaginable physical scale. A single major solar flare, one of the absolute most energetic flares ever recorded on the active surface of our Sun, is equal in raw power to more than 200 million hydrogen atomic bombs detonating simultaneously. That single outburst contains a sufficient amount of raw energy to successfully power the entire human race's modern energy consumption for something like 2 million years. Each of these massive solar flares shines as brightly as 400 billion trillion standard light bulbs turned on at once. But the visible light that we can see with our eyes represents only a tiny fraction of the total destructive energy that the event emits into space. They simultaneously unleash intense radio waves, extreme infrared heat, high-energy ultraviolet light, and even lethal X-rays. All of these dangerous elements are unleashed during every single flare at incredibly high intensities. These are, without a doubt, the single largest and most powerful explosions occurring inside our entire local solar system. Yet, despite their overwhelming power, the underlying physical force that drives these outbursts is incredibly simple. It is the force of pure magnetism. Our Sun possesses an absolutely immense, complex magnetic field. The massive amounts of energy stored up inside this field are what directly power solar flares. Vast, invisible loops of intense magnetic force are constantly pushing their way from the interior up toward the visible surface. Huge magnetic arches rise up high out into the open void of space. Whenever two of these complex magnetic field lines happen to cross paths, it instantly triggers a violent magnetic short circuit. This exact short circuit is what creates a solar flare. All of the energy that was trapped inside that specific segment of the magnetic field blasts outward at a temperature of 100 million degrees. It possesses the power to hurl superheated gas a billion miles out into the surrounding space. This represents a cosmic eruption that is 10 million times more powerful than any volcanic eruption ever experienced on Earth. The force of magnetism, the exact same physical mechanism that powers a simple, tiny compass on Earth, is what fuels the largest and most destructive explosions found in our entire solar system. Yet, when judged by wider cosmic standards, our local Sun is actually quite puny and weak. As we train our telescopes deeper into outer space, we observe stars that are vastly more active, displaying even more intense variations of magnetism. And when we examine those environments, things in the universe really start to get wild. There are active stars and exotic objects located inside our own galaxy, as well as in neighbouring galaxies, that produce flares of such extreme greatness and intensity that they would literally destroy all life on Earth if they were located anywhere near our system. Outside our local solar system, these titanic explosions violently rock the wider cosmos on a scale that human minds can barely begin to comprehend. Far beyond our Sun, we officially enter the terrifying realm of cosmic megaflares. Our Sun is inherently violent, firing off flares with the raw force of billions of atomic bombs. But as you travel further out into the deeper cosmos, the explosions get significantly bigger. Other stars across the galaxy experience flares so monumentally huge that they are classified as actual planet killers. Consider the star known as EV Lacertae, which is located 16.5 light years away from the Earth. Every single day, massive flares erupt across its active surface. But one specific mega flare smashed every single record ever written in astronomy. This star blasted out 10,000 times more lethal X-rays than the most powerful solar flare ever recorded from our own Sun. The corresponding ultraviolet light emitted during the blast was so intensely bright that the star actually turned completely blue to our instruments. This titanic stellar firestorm, despite occurring 100 trillion miles away, was so bright it was visible from Earth with the naked human eye. If our Sun ever flared like that, we would be instantly incinerated. But EV Lacertae is a very different kind of star compared to our Sun. It is tiny and falls into the category of a red dwarf. Red dwarfs are stars that possess much less physical mass than our Sun, ranging from 1/10 to about 4/10 of its mass. They are smaller, cooler, and are essentially dinky stars. They burn through their fuel so slowly that unlike our Sun, which will last 10 billion years, some red dwarfs will last for 10 trillion years. They are also relatively cold, with a surface temperature of just 5,000 degrees Fahrenheit, half that of our Sun, making them 10,000 times dimmer. Yet somehow they are capable of staggering violence. That is because red dwarfs are immensely magnetic. The magnetic fields that form inside them are enormous and much more powerful than our Sun's. That means the magnetic field energy released when those fields get twisted up is incredibly intense. And even though these objects are very dim, invisible light, they can produce flares that are thousands of times more energetic than those released by the Sun. You wouldn't want to be anywhere near one of those when it went off. All red dwarfs flare violently, but EV Lacerte's flares are off the chart. That is because it is very young, just 300 million years old, making it 15 times younger than our Sun. In one way, stars are a little bit like people. They're hotheads when they're younger. When stars are first born, they spin very rapidly, and that rapid rotation helps generate incredibly intense magnetic fields. The result is a star 100 times more magnetic than our Sun. When its giant magnetic loops cross, the resulting mega flare is colossal, unleashing a torrent of deadly radiation that lasts for 8 straight hours. Incredibly, even these massive flares are just a tiny flicker on the wider cosmic scale. There are eruptions out there that are millions of times brighter. These are explosions that can light up an entire galaxy from a tiny star with unimaginable power. Consider the Australia Telescope Compact Array, a network of 5 large radio dishes constantly listening to the whispers of the cosmos. In the year 2004, they were suddenly struck by a massive, overwhelming blast of energy. It was clear evidence of a mega flare, but this was bigger than any flare humanity had witnessed before. It was the single largest burst of power ever recorded from inside our galaxy. The object behind it is truly bizarre, a kind of star we didn't even know existed until this mega flare gave it away. For my money, the scariest single object in the galaxy is a magnetar. Magnetars are the most magnetic objects in the entire known universe, and this specific one beats them all. Its magnetic field is 1,000 trillion times stronger than our Sun's. If a magnetar ever came near our solar system, the effects would be devastating. The first thing you would notice is its magnetism would instantly wipe every credit card in your pocket. As you started to get closer, anything metal on you would be violently ripped away. Your earrings, your jewellery. Once you got within a few million miles of the magnetar, its magnetism would be so intense it would actually disrupt the electrical signals in your nerves, and your heart would instantly stop beating. Get even closer, and the magnetism would be so intense it would actually rip apart every single atom in your body. Amazingly, this vast magnetic field comes from an object no bigger than an ordinary asteroid. Our Sun is close to 1 million miles across, while the magnetar is just 10 miles wide, but it is unimaginably dense. It weighs more than our Sun. This is incredible. Take our Sun and squeeze it down, not just to the size of the Earth, but down to the size of Manhattan. The entire mass of a giant star is packed into a space the size of a city. You could almost walk around the star in a single day, except you couldn't because the gravitational field is so intense. The density of material on these stars is so great that a single teaspoon full of it weighs several thousand billion tons. You would be crushed beyond recognition in a fraction of a second. Dense and compacted, the iron-rich crust of the magnetar is under incredible magnetic pressure. Something has to give. Vast fissures rip across the surface, and the crust splits open, triggering a starquake. It's like an earthquake on Earth, except the crust literally moves just a half an inch. It's just a tiny shift, but that is a huge amount of energy because of the intense gravity. It is equivalent to a magnitude 30 earthquake. A flare erupts from the fracture, blasting a trillion-ton cloud of ultra-dense matter into space. It lasts just a tenth of a second, but it unleashes more energy than our Sun emits over 250,000 years. The energy emitted during a magnetar flare is, in some cases, more than 1 billion times the energy emitted by our Sun. Megaflares are also time machines, showing us events from long ago. This specific magnetar is 50,000 light-years away from Earth. The flare we observed in 2004 actually happened 50,000 years ago. It took that long for the light to travel halfway across the galaxy and slam into our atmosphere. If a similar megaflare exploded near Earth, we wouldn't even see it coming. We would have no warning if a magnetar were to have another flare like this. The event is so sudden and creates so much energy that it blasts out at the speed of light, and nothing can travel faster than light, so basically this just happens, and that's it. Any life within 10 light-years of the blast would be vaporized. Thankfully, even the closest known magnetar is located much too far away from us to pose a real threat to our planet. We cannot see these incredible entities using even our most powerful visual telescopes. We have only ever managed to find these hidden stars when they give themselves away during the brief, blinding flash of a massive megaflare. Yet, even these terrifying explosions are completely dwarfed by an even more powerful stellar monster lurking in the deep cosmos, second only to the legendary Big Bang itself in terms of physical scale. This phenomenon represents the absolute ultimate megaflare in the universe. Our story moves back 7.5 billion years into the deep past, many vast galaxies away from where we sit today, where a truly colossal supergiant star finds itself in catastrophic trouble. Its roaring nuclear centre has completely run out of fuel and energy. Without outward pressure, it is on the verge of a massive internal collapse. For a few fleeting seconds, the resulting explosion shines 1 million times more brightly than our entire home galaxy combined. This event is, without a doubt, the most extreme and violent type of explosion found anywhere in the known universe. It is a gamma-ray burster. Gamma-ray bursters possess such unimaginable power that they can easily be spotted right across the entire observable universe. They represent a display of raw power that is second only to the creation of the cosmos itself. During this event, 2 intensely focused jets of concentrated energy blast outward from the dying star. These dual beams of pure gamma-ray radiation function as the absolute ultimate mega flare. The sheer amount of energy packed into these events is completely beyond human comprehension. It equals the entire energy output that our own Sun will produce over its entire 10 billion year lifespan. Compressed and focused into just 2 beams that last for a mere few seconds of time, it acts as a massive cosmic blowtorch of pure gamma rays and superheated matter marching aggressively across the universe. Gamma rays represent the single highest energy, most intense variation of light in existence. They are naturally created by cosmic environments that are billions of degrees hot. There will never be a more intensely heated or powerful type of flare discovered in space. This is the absolute line where it stops, 7.5 billion years after that specific star collapsed in the deep void. Its light finally washes over our planet. We witness its radiation lighting up our sky in March of the year 2008. A sudden flare travelling from halfway across the entire observable universe momentarily shines more brightly to our instruments than the closest stars in our own celestial neighbourhood. Something blew up 7 billion light years away that you could actually see with your unaided human eye on a dark, clear night. That incredible fact should tell you something truly profound about the scale of this blast. It stands as the largest single flare ever witnessed by our species. But this bright flash is also the definitive physical signal of the birth of the single most destructive entity in the cosmos. A brand new black hole has officially formed inside the collapsing core of that dying supergiant star. It systematically consumes the material of the star from the inside out. By the time the outer layers of the star finally explode in a spectacular, catastrophic supernova, all that is left behind in the centre is a newborn black hole. Usually when astronomers look out into outer space, we are observing old black holes that have been around for millions of years, but to actually witness a baby black hole being born in real time is an absolutely incredible event. And that birthing process is exactly what we think a gamma-ray burster is. Amazingly, these gigantic cosmic explosions are surprisingly common across the universe. Our satellites detect more than 350 of them every single year. We see them occurring practically every day. Our specialised sensors spot them every few hours, firing off in all directions outside the boundaries of the Milky Way galaxy. These gamma-ray megaflares reveal one of the universe's most awesome secrets. A brand new black hole is born out there every single day. Fortunately, most of these terrifying explosions happened a very long time ago in regions positioned far away from the Earth. But if a gamma-ray burster were to ever go off inside our own home galaxy, the results would be catastrophic for our planet. If you were to place a gamma-ray burst just 100 light-years away from the Earth, the event would be exactly like detonating a 1 megaton nuclear bomb over every single square mile of the planetary surface facing the blast. You would essentially be detonating millions upon millions of nuclear weapons across the atmosphere of the planet all at once. It would signify the absolute end of all life on Earth, as we know it, forever. Gamma-ray bursts are the undisputed kings of megaflares, but they do not represent the most immediate danger to us. The single greatest cosmic threat to human civilization sits terrifyingly close to home, resting right at the absolute heart of our own solar system. For a very long time, humanity lived in blissful ignorance, feeling perfectly safe inside our quiet solar system. Now, modern science has proven that the Earth sits directly inside a cosmic firing range. Monster mega flares are erupting everywhere we look across the stars, but the single deadliest cosmic weapon of all is parked directly on our doorstep, our own sun. We have been lulled into a false sense of security, thinking that our sun is completely static, benevolent, and our gentle friend. We are completely wrong. The sun is highly dynamic and active, and in a certain physical sense, it is very much alive. It generates magnetism on a scale that our minds can only barely begin to comprehend, and its most powerful weapon of all is a coronal mass ejection, commonly known as a CME. During a CME, a colossal solar explosion rips a massive chunk of the star's own material away and torpedoes it directly out into the open void of space. Coronal mass ejections are closely related to standard solar flares, but they occur on a significantly larger scale. You can easily visualize a standard solar flare as being like a powerful tornado, very intense, highly focused, and short-lived. In contrast, a coronal mass ejection functions like a massive hurricane. It packs much more total energy, covers a far larger area of space, and its effects can last for days and days. CMEs always begin with a major magnetic short circuit on the Sun. Gigantic magnetic arcs push their way out from the surface, glowing intensely with trapped superheated solar matter. When these lines twist and cross paths, it triggers a massive firestorm of pure energy, causing the Sun to erupt. Solar matter explodes violently away from the surface and shoots out into space. This creates a monstrous, expanding cloud composed of superheated gas and highly charged electrical particles. When one of these huge solar prominences is launched into space, an amount of energy equivalent to about 10% of the entire brightness of the Sun for a second is released directly toward the Earth. Over 10 billion tons of physical material is shot out at a mind-boggling speed of more than 1,000,000 miles an hour. The raw power of a coronal mass ejection is truly mind-numbing. It takes our most advanced robotic space probes years of travel to cross the distance from the Earth to the Sun. A fast-moving coronal mass ejection can cross that exact same distance in just a couple of days, and sometimes in only a matter of hours. These are tremendously powerful and dangerous events, and they become deadly because every once in a while the Sun shoots one of these massive CMEs straight toward the Earth. When that crackling charged cloud hits our planet, it plays absolute havoc with human electronics. It possesses the power to melt heavy regional power grids, blow out electrical fuses, and completely disrupt global communication systems. But that is absolutely nothing compared to the structural damage that a truly massive CME could inflict upon our modern world. A supersized solar storm can easily wipe out our orbiting satellites, crash our GPS networks, and completely destroy the global internet infrastructure. All sorts of absolute havoc can take place when this giant electromagnetic tsunami hits the Earth. The financial damage inflicted upon our space satellites alone would total over $100 billion. Think of a massive blackout that knocks out power not just to a single city or state, but across hundreds of major cities around the planet all at once. The total global property damage would easily reach about $2 trillion. We are talking about an event that could trigger a complete collapse of modern-day human civilization. We would be thrown back 50 or 100 years into the dark past, forced to survive in a world entirely without electricity. Thankfully, these massive, world-altering solar storms are relatively rare events. On average, a truly catastrophic CME strikes the Earth only once every 500 years. But it has happened before in history, and it will inevitably happen again. In the year 2003, we recorded one of the largest coronal mass ejections ever observed by human science. But fortunately for us, its path missed the Earth entirely. One of these days, a massive storm is going to hit the Earth directly. One of these days, one of these solar rifle bullets will be aimed right at us. And at that point, human civilization had better watch out. Our planet is under constant attack. We are exposed to danger not just from distant megaflares in deep space, but from our very own parent star. The Sun fires billions of tons of hot gas and charged electrical particles into space every single day. These are deadly solar weapons, and sometimes they are pointed straight at us. What I find completely amazing is the fact that the Earth manages to sit right in the middle of this cosmic shooting gallery, yet we have somehow survived this continuous bombardment. We are alive because we are incredibly well protected. The Earth possesses its own natural magnetic field. By cosmic standards, it is incredibly weak, but it is just enough to keep us safe from the Sun. To put its strength into perspective, think of an ordinary basic magnet that you use to stick notes onto your kitchen refrigerator. That simple kitchen magnet actually has more physical magnetism than the entire global magnetic field of the Earth. Without our protective magnetic shield, every incoming CME would completely strip away Earth's atmosphere, and we would all be instantly fried by solar radiation. How do we know this for sure? We know because this exact disaster happened to one of our closest planetary neighbours. Look at the planet Mars. Mars is a perfect example of what happens to a planet when it loses its magnetic field. Today, Mars is a frozen, lifeless desert with an atmosphere that possesses only 1% of the atmospheric density found on Earth. It looks this way because it completely lacks a global magnetic field. Over the course of billions of years, the Sun's charged particles have systematically stripped away Mars's air. which is the exact reason why it has such a thin atmosphere today. Here on Earth, we are lucky enough to have a strong magnetic field and plenty of air to breathe. This setup is not a coincidence. We can breathe today because of our magnetic field. From the safety of the Earth's surface, resting comfortably beneath our invisible magnetic umbrella, we can directly witness the power of our violent sun in the form of the northern and southern lights. Trillions upon trillions of charged electrical particles from the sun strike our planet every single second. Our magnetic shield safely funnels these particles away from the equator and drives them toward the north and south poles. As they enter the atmosphere at the poles, they collide with and energize gas molecules in our air, making them visibly glow in the dark. It is a stunning chemical light show. Oxygen molecules shine a vibrant green, while nitrogen glows in shades of blue or red. These auroras serve as beautiful visual evidence of a colossal battle currently raging between two opposing magnetic fields. The Sun's field creates destructive CMEs, while the Earth's field shields human life from them. Magnetism is truly one of nature's most mysterious and invisible forces. Only now is modern science beginning to truly understand how it shapes the wider cosmos. Megaflares make this invisible force visible to our eyes. They shine a bright light on the incredible power of magnetic fields. These are fields that play a fundamental role in organizing the universe. They help impose order onto absolute chaos. They weave their way through the massive spiral structures of entire galaxies. We are discovering fields that stretch hundreds of thousands of light years across, yet are 100,000 times weaker than the Earth's field. Smaller magnetic fields exist inside the boundaries of galaxies, organizing scattered matter into massive clouds of molecules. This process gives birth to spectacular nebulae. These stellar nurseries are the exact locations where brand new stars are born. Now we have discovered that magnetic fields even permeate completely empty space. These wide magnetic structures were originally generated during the explosive events of the cosmic Big Bang, possessing an intensity that measures just 1/4 of the magnetic strength found on our own planet Earth. This fact proves that we live inside a fundamentally magnetic universe. What makes this data so completely mind-boggling is that this completely invisible mechanism, these quiet magnetic fields, happen to execute such an unimaginably critical role in managing every single structural aspect of the wider universe. They provide us with a vital shield protecting our lives from the dangerous radiation streaming continuously from our sun. They govern the explosive outbursts occurring on volatile red dwarfs. They rule over the crushing dynamics of exotic magnetars, and they direct the absolute most energetic and violent physical processes observed across the entire known cosmos. Magnetism also plays an equally massive role on every conceivable scale of the universe during the catastrophic outbursts of gamma-ray bursters, systematically altering the physical structural dynamics of giant objects and rendering the universe an incredibly violent, unpredictable and fascinating destination. These massive megaflares effectively illuminate the dark corners of our cosmos, shining a brilliant spotlight on hidden features and physical processes that human beings would otherwise be completely blind to. They allow us to directly witness events streaming from the opposite side of the observable universe, or travelling to us from billions of years in the deep past, showing us the exact moment a terrifying new black hole is born in the dark. Let us shift our focus back to our own local neighbourhood, our familiar solar system. This system is composed of 8 distinct major planets, more than 150 identified moons, billions of stray space rocks, and a massive collective arrangement of dust and gas. All of these distinct physical components steadily move around a single central star, travelling together inside a giant whirling planetary disk that measures roughly 10 billion miles from side to side. The system has successfully maintained this specific structural arrangement for more than 4 billion years of continuous history. Every single object inside this disk moves along in a highly orderly, predictable fashion, presenting an image that appears remarkably serene, quiet, and stable. However, modern astronomy has proven that our local solar system is actually highly unusual and unique. Elsewhere across the vast wider universe, planetary orbits look absolutely nothing like our calm setup. Out in the stars, orbits are inherently unstable, deeply chaotic, and can even become completely destructive to everything around them. Even when we observe the relatively nearby universe, we can easily locate incredibly violent and terrifying examples of orbital mechanics in action. We see massive giant planets that aggressively hurl themselves inward toward the blistering surfaces of their parent stars. We witness intense atmospheric shockwaves radiating thousands of degrees of heat as they perpetuate violently through the outer layers of these worlds. There are actual planets out there that dip down directly over the active, roaring surfaces of other companion stars. We see massive stars spinning around one another in complex binary systems, and highly complicated multiple orbital configurations where absolute chaos rules the day, causing entire planetary objects to be violently kicked completely out of the stellar system. There are giant stars actively gobbling up other neighbouring stars, terrifying black holes systematically eating up entire local star systems, and massive galaxies violently colliding directly with other galaxies. In the universe, that structural chaos is the absolute standard norm. Our planet Earth functions as a beautiful, isolated oasis of liquid water and comforting warmth. Living organisms can successfully flourish here simply because of the exact way our planet orbits around the central sun. The orbital path of the Earth is almost a perfect, flawless circle. Because of this circular route, we manage to remain at roughly the exact same physical distance from the sun's heat source all year round. Consequently, the overall environmental temperature on our planet remains relatively constant and predictable, and this specific orbital path has remained completely stable for the past 4.5 billion years of terrestrial history. Without this absolute long-term structural stability, human beings would simply not exist today. To successfully construct complex strands of DNA directly out of the chemical soup of primeval oceans requires hundreds of millions of years, and perhaps even a full billion years of continuous environmental peace. And to achieve that long-term environmental peace, a planet absolutely requires highly stable, circular orbits. And so, without the deep stability of our local solar system and the reliable nature of the Earth's orbit, there would be absolutely zero life on our world. We owe our entire existence to the precise geometry of Earth's orbit. Human civilization gets a remarkably smooth, gentle ride inside an otherwise brutally violent and hostile universe. We have essentially hit the absolute grand orbital jackpot of the cosmos. Yet, despite our good fortune, absolute chaos is never located very far away from us. Even when we limit our observations to the interior of our own local solar system, we can easily find extremely harsh and violent orbits where living things could never manage to survive. Consider the planet Mercury, which stands as the single closest rock to our Sun and holds the record as the smallest major planet inside our system. Its specific orbital path stretches out into a highly distorted, elongated oval shape. When it reaches its furthest point away from the Sun, Mercury sits about 43 million miles from the heat source. But when it loops around to its closest position, that distance shrinks down to a mere 28 million miles. When it snuggles up this incredibly close to the Sun, the environment gets unbelievably hot. The temperature skyrockets to 800 degrees Fahrenheit, which is significantly hotter than the interior of a commercial baker's oven. Furthermore, because there is virtually zero atmosphere existing on the surface of Mercury, a human visitor would instantly choke to death. And because there is no ambient air pressure to speak of, the natural liquids and blood inside your body would instantly begin to boil, which would quickly burst your skin from the inside out. As a consequence of this rapid decompression and boiling, you would literally explode if you were to step out onto the surface of Mercury. But the temperature variations on this rock do not stop at extreme heat. The environmental temperature can simultaneously plummet down to a freezing 300 degrees below zero on the dark side, which is 3 times colder than the absolute coldest location ever recorded on the surface of the Earth. Mercury experiences the absolute most extreme and violent temperature shifts of any major planet inside our entire solar system. But it also serves as definitive proof that planetary orbits do not simply follow a static loop. With every single revolution it completes around the Sun, Mercury's spatial path gradually shifts over. Over the course of thousands of years, this shifting route causes the planet to follow a pattern that resembles a giant daisy drawn in space. Let us travel all the way to the opposite end of our local system, where we find the small body Pluto resting a massive 4 billion miles away from the Sun. The further away an object is positioned from the central gravitational source, the slower its overall orbital speed becomes. Because of this immense distance, Pluto requires 248 Earth years just to complete a single loop around the Sun. Furthermore, Pluto represents a major orbital anomaly in our system. Its highly stretched elliptical orbit is tilted on a completely different geometric plane compared to the paths of the major planets. And this unique setup gives birth to an absolutely amazing environmental spectacle. During the vast majority of its long year, Pluto exists as a completely frozen, dormant block of solid ice and rock. But as its oval path gradually carries it closer to the Sun, a brief planetary summer begins to take hold. When Pluto warms up even a little bit, the frozen chemical ices resting on its surface, which include water ice, solid carbon dioxide, carbon monoxide, and methane ice, begin to actively evaporate through sublimation. This rapid evaporation creates a thin fog, and as the world moves closer, the fog gets continuously thicker. Then you suddenly witness the formation of a thick cloud layer, giving birth to an actual planetary atmosphere around Pluto that simply wasn't there before. This temporary atmosphere reaches its absolute peak thickness when Pluto passes through its closest point to the Sun. But as the planet's path inevitably swings it back out into the deep freeze of outer space, the environmental temperature rapidly plummets to more than 400 degrees below zero. At this point, it begins to actively snow across the world, dropping frozen flakes composed of solid nitrogen and methane gas. As the bitter cosmic winter approaches, these atmospheric gases slowly freeze completely out of the air. They may rain down in a gentle, snow-like fashion at first, but over time they gradually accumulate to form a glassy, semi-transparent layer of solid ice, creating a frozen, fallen atmosphere resting directly on the surface of Pluto. After enduring this long, bitter winter freeze, Pluto's orbit eventually drifts back closer to the Sun, and the 248-year environmental cycle begins all over again. Extreme environmental transformations like these serve as a vivid reminder of just how incredibly lucky human beings are that the Earth's orbit is so exceptionally stable, uniform, and benign. But the truth is that this safety is based on a highly delicate gravitational balance. The smallest structural change to our orbit could easily kill every single one of us. If the Earth's orbit were to shift even a little bit closer to the Sun, our planet would transform into a replica of our closest neighbour, Venus. Venus stands as a perfect, terrifying example of exactly what would happen to the Earth if our orbital path ever shifted slightly inward from where we sit right now. Venus possesses a monumentally thick, crushing atmosphere that acts as a giant thermal blanket, permanently trapping all of the incoming solar heat and driving the surface temperature to a melting 900 degrees. If we moved even a fraction closer to the Sun, we would suffer the exact same runaway greenhouse effect as Venus. Our vast oceans would completely boil away into space. Our entire planet would transform into a dead desert, and all known life would be utterly destroyed. Conversely, a small orbital shift in the opposite direction away from the Sun would bring a completely different disaster. Instead of boiling, our world would freeze solid. You would quickly end up with a complete snowball Earth, a planet completely encased from pole to pole in a thick shell of solid ice, and that catastrophic transformation could be triggered by moving the Earth by only a tiny fraction of its current distance from the Sun. The polar ice caps would rapidly expand over the continents. The oceans would freeze solid into glaciers, and a permanent terminal ice age would take over the planet. A tiny alteration in the Earth's orbit means that human life dies by fire or by ice. Orbits possess the unique capability to allow life to grow and flourish, but they are equally capable of generating absolute systemic chaos. In fact, violent orbits are even capable of systematically tearing apart and destroying entire stars. Our own planet's orbit makes life possible, but the reality of the cosmos is that most orbits are inherently violent environments. Outer space functions as a massive cosmic freeway. Absolutely nothing in the universe stands completely still. Everything is in constant aggressive motion around everything else, and this entire cosmic dance is driven by a single fundamental mechanism, the force of raw gravity. Gravity represents the universal force of mutual attraction that spreads its invisible influence throughout the entire fabric of the universe. It is the exact binding force that holds individual stars together, and it is the single mechanism that binds our entire solar system together in the dark. Every single physical object in existence generates its own gravitational pull, meaning that all objects are constantly attracting each other across space. The more physical mass an object possesses, the stronger its internal gravitational attraction becomes. That is the exact reason why a falling apple is pulled directly down toward the surface of the Earth. Inside our local system, the single largest and heaviest object by far is the Sun. It is a staggering 700 times more massive than all of the planets, moons and asteroids put together. The titanic, crushing force of the Sun's dominant gravity is constantly pulling all of the planets inward, trying to swallow them, but something very specific stops them from falling directly into the stellar fire. The planets are in constant high-speed motion. They fly through the vacuum of space at incredible speeds, travelling not directly toward the Sun, but sideways relative to it, creating a continuous gravitational tug-of-war between the Sun's inward pull and the planet's forward velocity. When these two opposing forces perfectly balance out, the planet enters a continuous loop around the Sun. Scientists refer to this balanced spatial path as an orbit. An orbit is simply the continuous path of an object travelling around another object due to the influence of gravity. Depending on the specific balance of speed and mass, you can have perfectly circular orbits, or you can have highly elongated elliptical orbits. Even if I were to take an ordinary ball, throw it up into the air, and catch it a second later, that ball technically entered a very brief orbital path around the true centre of the Earth. It is simply physical motion altered by the pull of gravity. Imagine what would instantly happen if our sun suddenly lost its gravitational pull. The forward speed of the planets would immediately shoot them out of the system, launching them into the dark void like stones from a slingshot. On the other hand, if the planets were to suddenly stop moving forward, gravity would win instantly, pulling them directly into the sun to be incinerated. Every single orbit in existence represents a continuous, delicate balance between gravity and forward motion. We like to comfort ourselves with the idea that the wider universe runs perfectly like clockwork, with everything remaining neat, orderly, and predictable. We imagine the planets moving along in a state of eternal cosmic harmony. But that comforting image is completely wrong. Orbits can easily become completely wild, erratic, and unpredictable. And the more individual objects you add to a specific system, the more deeply chaotic and unpredictable their orbits become. Things get incredibly complicated when you have more than two large objects all attempting to orbit around each other at the same time. When that configuration occurs, an orbital path can actually begin to loop wildly between one object and another, and planetary speeds can violently accelerate or slow down over brief periods. An orbit does not have to remain a clean, regular, repetitive path. The universe's endless creativity constantly defies our human scientific imagination. If we travel far out beyond the orbit of Pluto, travelling halfway to the nearest neighbouring star, we enter a realm populated by trillions of comets, chunks of solid ice and rock. They float quietly in vast spherical clouds, existing as the completely frozen, pristine remnants left over from the very dawn of our solar system. Every single once in a while, one of these frozen bodies loses its balance and begins to fall directly towards the sun. They can start their journey a full trillion miles out in the dark, moving almost imperceptibly slowly, and then fall all the way down to whip directly above the burning surface of the sun. When they are far away, they are hardly moving at all, but by the time they are whipping past the sun, they are travelling at absolutely blistering speeds. Because of this radical acceleration, comets track some of the most extreme and violent orbits found inside our entire solar system. Their paths can become so radically elongated that they resemble a straight line rather than a loop. During their closest approach, comets can travel at speeds up to 1,000,000 miles an hour. They function as literal cosmic missiles, guided blindly through the dark by the interplay of gravity and speed. Comets demonstrate to scientists just how incredibly destructive orbits can become. Many of them end their journeys by plunging directly into the sun or by violently crashing into major planets. If a large comet, perhaps measuring 5 or 6 miles across, were to ever collide directly with the planet Earth, you had better watch out. It would act as a definitive planet buster. It would represent an object of sufficient scale and speed to completely wipe out all life as we know it on our world. Planets, by their very definition, are supposed to travel in circles around stars. Because of this foundational baseline rule, human astronomers were completely shocked and blindsided to find actual rogue planets. The term rogue planet is a complete contradiction in terms. It refers to planets that exist out there entirely, without a mother star to call home. Scientists currently believe that every single rogue planet drifting through the dark void did once orbit around an ordinary star until massive gravitational forces violently hurled them away from their parent systems. Newborn solar systems are incredibly chaotic, volatile, and unstable places. In these early environments, massive sibling planets constantly tug on each other gravitationally and dramatically alter each other's developmental course. Some unfortunate planets even spiral all the way out of their systems to wander the massive galaxy entirely alone. The widespread presence of rogue planets shows us that the force of gravity is not just an attractive mechanism which quietly binds a local solar system together. It possesses a dark side, functioning as a force that can also violently fling entire planets into empty outer space. A recent comprehensive sky survey strongly suggests that our own home galaxy contains far more of these rogue planets than it does actual stars. We have successfully discovered unique orbital configurations that we didn't even know were physically possible. Gravity and spatial motion keep our vast universe in a state of constant, aggressive turmoil. Monstrous orbiting suns actively cannibalize each other. Violent gravitational vortexes distort the very fabric of space itself. And immensely powerful forces can flick a massive star like a spinning top on a table. Gravity causes absolute chaos on an epic scale across the cosmos, routinely hurling planets to their ultimate destruction, or firing them off into the freezing void of space. But the cosmic roller coaster gets even more extreme than that. Orbits can become so fundamentally violent that they physically rip massive chunks out of living stars. Consider the binary star system known as HM Cancri, which sits roughly 16,000 light-years away from our home planet Earth. These two objects are white dwarfs, which means they are small in physical size but are unbelievably dense. To help visualize this, a single teaspoon of white dwarf matter can easily weigh 5 tons. These two stars are separated by a mere 50,000 miles, placing them 5 times closer to one another than the Earth is to our Moon. They circle each other at a blistering speed of more than 1,000,000 miles an hour. We are looking at two white dwarfs separated by an infinitesimal distance, rotating around each other in just 5.5 minutes. This sets an absolute world record for an astronomical body moving in space. The forces generated in this tight space are completely immense. Gravity aggressively rips superheated gas out of one star and slams it directly into the surface of the other. Scientists believe that this specific orbit is so incredibly violent that it actively warps the fabric of space itself. In the process of this warping, the two stars continuously lose their orbital energy, which causes them to fall even closer together over time. Eventually, they will inevitably collide directly with one another, creating a massive supernova explosion. A supernova is one of the most violent and energetic events occurring in the universe today. You are talking about completely blowing up a star. There is simply no way to adequately describe that kind of raw energy. Some supernovas are so monumentally powerful that they are second only to the Big Bang itself in terms of energy and sheer power. They are so magnificent that they can easily outshine an entire galaxy composed of 200 billion stars. Supernovas can also give birth to one of the absolute weirdest categories of objects in the entire universe, a pulsar. Pulsars are intensely magnetic stars. They fire out concentrated beams of electromagnetic radiation that sweep across space like a lighthouse. There are very few things in the known universe more dramatic than an active pulsar. Imagine a solid ball that is about 10 miles across, rotating hundreds of times a second with an internal density that is almost unimaginable. 1 cubic centimetre of this material would have as much mass as Mount Everest. If you were standing near it, you would feel a gravitational pull that is millions upon millions of times what you are feeling sitting on the surface of the Earth right now. You wouldn't just be crushed flat by this gravity. Your body would be completely crushed into a paste that is only a few atoms thick. Anything that attempts to orbit a pulsar too closely risks being torn to shreds by these tidal forces. This brings us to the Black Widow pulsar. It rips through our galaxy at a speed of 600,000 miles an hour. The shock wave generated by its high-speed movement is so vast that our telescopes can easily detect it from 5,000 light-years away. Travelling alongside it is a companion brown dwarf, an object that is bigger than a planet but smaller than a star. The pair are locked in an orbital dance of death. The Black Widow pulsar, in a very real sense, acts like a cosmic vampire, actively sucking the lifeblood away from this brown dwarf star, eating away at its hydrogen and helium fuel. Intense radiation blasts the brown dwarf's atmospheric gases directly into space. A pulsar that measures just 10 miles wide is systematically destroying an object that is bigger than Jupiter. Eventually, the brown dwarf will completely evaporate into nothingness. A single pulsar possesses immense destructive power, but two pulsars locked together can literally change the shape of the universe. This is the only known double pulsar system inside our galaxy, orbiting each other at 700,000 miles an hour. Their immense speed and combined mass cause them to spin chaotically. It is incredible to think of the enormous forces gravitationally that these two stars exert on each other, causing the whole geometry, the entire architecture of the system, to change and spin around like a top on a table. The gravity of the heavier pulsar makes the smaller companion wobble erratically. It whips around so violently that the whole star almost tips over, just like a spinning top losing its balance. It cannot last forever. 85 million years from now, the two pulsars will merge together to form a vast gravitational abyss. They will create the universe's ultimate monster, a black hole. A black hole stands as the most extreme object in the universe. At its centre, the known laws of physics break down entirely. Time comes to an end. Gravity becomes infinite. A black hole is essentially a bottomless pit of gravity caused by the death of a star. There is nothing in the universe more mysterious than how black holes work. If you want to talk about extreme orbits and extreme gravity, you are talking about black holes. That sits at the absolute top of the list. Nothing has stronger gravity than a black hole. It is the mass of something like the sun or more, compressed down into a ball that's only a couple of miles across. 50 years ago, black holes were dismissed by mainstream science as pure science fiction, but not anymore. Now we see them sitting at the centre of galaxies and wandering through outer space. Black holes, we now know, are central to the evolution of the universe. We now think there may be 100 million black holes inside our galaxy alone. An encounter with any of them leads to absolute oblivion. Consider one of the largest and hottest stars in the universe. It is 20 times more massive than our Sun and 10 times hotter. Stars like this never live long. But this specific one is locked in a diabolic waltz, trapped tightly in the grip of a nearby black hole. The gravity here is so powerful that the star orbits at 500,000 miles an hour. The black hole sucks the star's outer layers into a vast, swirling disk. This disk gets so incredibly hot that it blasts out X-rays 1,000,000 times more powerful than our Sun. This configuration, a star orbiting around a black hole, is extreme and highly unstable. First of all, the black hole is continuously eating away at the atmosphere of its companion star, but the star itself is inherently unstable. It will one day undergo a supernova and perhaps leave a black hole in its wake, and then we'll have two black holes rotating around each other, which is one of the rarest sights in the universe. Eventually, these black holes will merge to create a new, larger monster, and the cycle of destruction will continue. But this specific black hole is relatively small. Other black holes take violence to a whole new level. In the year 2011, astronomers witnessed one of the biggest explosions ever recorded in human history. It was a flash of radiation brighter than 100 billion suns, a gamma-ray burst. It was a spectacular event. The burst came from a supermassive black hole at the centre of a distant galaxy. It had been dormant, but something had shocked it back to life. If you pass by the event horizon, an imaginary sphere surrounding the black hole, you cross the point of no return. It's like the ultimate roach motel. Everything checks in, but absolutely nothing checks out. Several stars were orbiting this black hole at a safe distance. Then one of them got just a little bit too close. The sleeping giant suddenly awoke. Immense gravitational forces stretched the star to its absolute breaking point until finally it was torn apart. Debris swirled around the black hole, heated to millions of degrees. Two giant jets of gamma rays blasted into space at the speed of light. A black hole has torn a star apart, swallowed up half of the material of the star, and ejected the other half in an event that is among the most violent things we have ever seen in the history of astronomy. The event was so violent we saw it from Earth 3 billion light years away. Black holes can suck in planets and rip apart stars, but gravity doesn't always pull things in. Any high school student knows that gravity sucks. It pulls. It never pushes. But it's actually more complicated than that. That is true when you just have two objects. But the minute you have more than two objects, strange things can happen and gravity can actually push you away. You can get very close to a body, but if you come in at just the right angle and just the right speed, instead of colliding together, one object can slingshot the other one away. Recently, scientists discovered stars hurtling away from our galaxy at incredible speed. Normal stars don't do this. So, what could accelerate a star to hypervelocity? The answer was a surprise. You can only eject stars at these very, very high velocities, close to 700, 800 or 1,000 kilometers a second, through interactions with a supermassive black hole. Each hypervelocity star was originally one of a pair of stars orbiting a supermassive black hole. When they got too close, gravity pulled them apart. The black hole catapulted one star out of the galaxy at 2 million miles an hour. Eventually the other was sucked in and destroyed. The interesting thing here is that you can get a complete redistribution of stars. So you have stars that are in the centre of the galaxy, and suddenly they're ejected out into intergalactic space. And it's out here in deep space that orbits are at their most powerful, smashing entire galaxies together to create the structure of the universe itself. Across the universe, extreme gravity is a force of destruction. The orbits of planets and stars can be chaotic, unpredictable, and violent. But on a truly cosmic scale, gravity is no longer just a destroyer. It also creates new worlds. These are galaxies, giant spinning clusters of stars, gas and dust, measuring 100,000 light years across. Galaxies orbit each other in the same way planets orbit stars. Gravity pulls them together. Their speed keeps them apart. But ultimately, gravity always wins. Entire galaxies smash together. One of the most spectacular events in the universe is when galaxies collide. You're talking about hundreds of billions of stars, 100,000 light years across, two of these things slamming into each other. Collisions between orbiting galaxies take place over millions of years. Gravity slowly pulls them together and you get these two galaxies that merge like two fluids mixing together. And you get long tidal tails as they pass through each other, but then gravity brings them back together again. And in the end, you get a full-fledged, more mature, larger galaxy than you had originally. On this intergalactic scale, gravity and motion are no longer destructive forces. Now they trigger the creation of life itself. You would think a galactic collision would be incredibly destructive, and in one sense it is, but in another sense it's a very creative force. Colliding galaxies smash vast gas clouds together. Huge shockwaves rip through them, squeezing the gas. Then something amazing happens. The birth of countless stars. It's incredible to think about two galaxies that gravitationally attract each other and collide. What could be more destructive? But in fact, there's a power of construction in such mergers because as two galaxies come together, the gases are compressed. And sometimes the gases are compressed so much that you get the birth of stars and the associated planets around those stars. And so in the titanic collision between two galaxies, you can get the birth of stars and planets, and perhaps eventually life on those planets. Sometimes these collisions trigger a chain reaction. We can see two spiral galaxies in mid-collision, creating stars and planets. But this time, there's a difference. Some of these new stars are massive, unstable, and short-lived. They explode. Each explosion blasts out new shockwaves and triggers the birth of even more stars. Astronomers call this a starburst. It's the ultimate example of gravity's creative power. A starburst galaxy is one that is creating stars at a much higher rate than we usually see in normal galaxies. And so it's amazing that you can have such a beautiful creative process coming out of something so violent and destructive. Gravity and motion, the two forces that give birth to every new star, also weave together the fabric of the universe itself. Our cosmos is not random, it has structure. The universe is a vast three-dimensional tapestry. Each of these threads and filaments contains billions of galaxies. It's the scaffolding that holds everything together, the cosmic web. When we think about the scaffolding of a building, it's just sitting there, static. But in fact, this scaffolding is quite dynamic and quite amazing, because all of the constituents are moving around at very high speeds, crashing into one another. Galaxies, stars, black holes, supernovas, all in this tremendous cosmic dance. The cosmic web is incomprehensibly vast. Each thread is full of motion. Galaxies form, orbit, and collide, countless billions in a constant stream. Every filament is a galactic freeway with an endless flow of traffic, each point of light a galaxy. It's rush hour 24/7, and sometimes there's gridlock. Every billion light years, several filaments join to form a knot. Whole clusters collide to form some of the largest structures we know of. Superclusters. This is one of them. Abell 2744. 5 orbiting galaxy clusters crashed together in the single biggest cosmic pileup ever discovered. Gradually, the 5 clusters merged and fused to form a single giant supercluster 6 million light-years across. The incredible power of orbits can literally tie the universe in knots. Structures in the universe have evolved over billions of years through their orbits and their mutual gravitational attraction, and they've built up into larger and larger structures. And it's all thanks to these same attractive forces that bring them together, but can also tear them apart. Again and again we discover orbits dominating the cosmos. The atom is the basic unit of chemistry. In the same way, the orbit is the basic unit of the universe itself. If you understand all possible orbits, you understand the dynamics driving the universe. Orbits have created a cosmos full of richness and complexity. Orbits are changeable. They're chaotic. Things that we never thought were possible are in fact possible. From the smallest scale to the largest scale, it's the gravitational interactions and collisions that actually make our universe the beautiful place that it is. Witnessing a dramatic glowing streak of light flashing all the way across the dark night sky because of a passing comet is an absolutely astonishing and unforgettable sight. Comets are inherently beautiful cosmic objects. They look to our eyes like fuzzy, glowing balls of illumination that feature a massive, sweeping tail of material coming off the back. It is truly quite something to look at. An ordinary person simply does not get the opportunity to observe a majestic object like that very often in their normal life. Comets are completely extraordinary entities. If you happen to catch a glimpse of a major comet for the very first time in your life, that specific visual memory will undoubtedly stick with you forever. The overall physical journey that a comet takes as it sails aggressively through the interior of our solar system is easily the most fantastic, grand odyssey of all the unique astronomical objects found in space. A comet loops its way inward toward the heat of the sun, travelling all the way from the deepest, darkest depths of outer space. This represents an incredible cosmic odyssey that can easily last for millions of continuous years. Many of these comets happen to pass by the vicinity of the Earth so frequently that they are almost like old, familiar planetary friends returning to visit us. At its physical core, every single comet exists as a frozen mass composed of solid rock and dirty ice that measures several miles across. But when we look up from the ground, all we can actually see with our naked eyes is a magnificent, glowing ball of light and a long sweeping tail trailing out behind it. Yet, comets represent significantly more than just pretty, automated cosmic fireworks in the night sky. They could actively help our species unlock some of the absolute deepest, most profound mysteries in all of modern science. Human scientists are constantly trying to figure out exactly where we originally came from. That means answering everything starting from the absolute beginning of the wide universe, moving to the physical formation of our local solar system, and tracking down exactly how living organisms originally got started on our world. Comets fit into that grand scientific puzzle beautifully. They give us critical, unblemished clues regarding exactly how our solar system originally formed. If we are completely unable to understand comets, then we will never truly understand how human beings managed to get here in the first place. In fact, comets may very well be the absolute source of life itself. We may owe our entire physical existence as a species to the historical reality that comets crashed into the Earth billions of years ago and delivered the necessary chemical ingredients for life to successfully get off the ground. But at the exact same time, these massive objects can also cause a staggering amount of absolute global destruction. Comets possess the literal power to kill every single one of us. If a large comet were to ever execute a direct impact with the planet Earth, you had better watch out. It would act as a definitive planet buster. It represents an object of sufficient scale and mass to completely wipe out all life as we currently know it across the entire globe. We must learn absolutely everything we can about comets, because just maybe that crucial scientific knowledge will teach our species how to successfully survive an encounter with them, while simultaneously helping us understand exactly how the wider universe operates. When we actively investigate these icy objects, we are directly learning what the local solar system was like when it was first coming together in the dark, and we can apply that data to comprehend what other alien solar systems look like as they form around distant stars. Hopefully, that will teach humanity a tremendous amount about how stars form, how major planets form, and how comets themselves were originally put together by the cosmos. Comets possess a history that dates back to the very birth of our solar system, roughly 4.5 billion years into the deep past. They were originally assembled by the exact same physical force that created the rest of the solar system, the force of raw gravity. The process initially began inside a giant swirling maelstrom of absolute chaos. A colossal cloud composed of gas and interstellar dust began to catastrophically collapse under its own weight to form a fast whirling planetary disk. In regions located close to the central newborn sun, the environment was burning hot. But as you travelled much further out into the disk, it was cool enough to allow gas clouds to condense and freeze solid. Tiny ice crystals began to fuse directly with microscopic grains of cosmic dust. These clumps slowly pulled together through gravitational attraction into larger and larger physical masses. Over long stretches of time, these objects essentially snowballed in space, moving exactly like a snowball rolling down a steep hill, continuously picking up more and more surrounding material. Eventually, over millions of years, these growing bodies transformed into the massive gas giant planets like Jupiter and Saturn. But not all of the leftover debris spinning inside that original planetary disk managed to get incorporated into major planets. Trillions of individual lumps of dirty ice were completely left behind in the dark. These are the comets. You can easily think of comets as being the frozen leftovers from the original creation of our solar system. They have remained almost completely unchanged from that ancient era all the way to this very day. They function as pristine, unblemished cosmic time capsules. If you could somehow crack a comet completely open and analyse what is resting deep inside its interior, you could literally see the raw ingredients that the solar system was first made out of. That is an absolutely remarkable reality. But these comets did not stay in their original positions forever. Several 100 million years after the system formed, the entire solar system plunged back into a state of severe turmoil and disruption once again. Continuous gravitational encounters with surrounding debris pulled the massive gas giant planets completely out of their original orbits. The immense gravity of these shifting giants then began to hurl comets violently in every conceivable direction across space, flinging trillions of tons of pristine material from the dawn of the solar system straight into the cold, distant outer reaches of the cosmos. Some of these displaced comets eventually settled into a flat ring region located 4 billion miles away from the Sun, which we know today as the Kuiper Belt. But the vast majority of them were tossed significantly further out into the dark, forming a massive giant sphere that completely surrounds our entire solar system. Astronomers refer to this distant spherical shell as the Oort cloud. This represents the absolute furthest region of our solar system away from the Sun. From out at this extreme distance, our Sun appears as nothing more than a tiny, faint little dot of light, looking just like any of the other countless stars in the night sky. The entire region of space surrounding you in the Oort cloud is virtually empty. There is almost nothing out there. It is incredibly vacant. Only occasionally will you stumble upon an odd comet floating out there in the deep freeze, cold, dark, and very much alone in the void. Inside this remote frozen ice cloud, there are more than 1 trillion individual comets drifting in the dark. Because they sit so incredibly far away, they can require millions of years just to complete a single orbital loop around the Sun, but they do not always remain parked out in that distant graveyard. The orbit of every single comet represents a highly delicate gravitational balance. The absolute smallest physical nudge can easily tip the scale entirely. The vast majority of comets spend their entire long lifespans billions of miles away from the Sun, remaining completely motionless, inert, and simply waiting in the dark for something to happen. But then, perhaps a random collision takes place between two icy bodies. Or perhaps a passing star drifts close enough to give the cloud a tiny gravitational nudge. When that happens, the relentless gravitational pull of the Sun inevitably takes hold and begins to drag the comet downward into the inner solar system. The exact same force of gravity that originally created the comets and then flung them out to the edges of the solar system now pulls them back home. Our comet begins its epic high-speed odyssey across space, moving inward to spread either life or absolute death across the planets of the solar system. More than 1 trillion comets quietly circle our Sun at the frozen fringes of the system, but many do not stay parked out there forever. The smallest gravitational disruption can instantly knock them completely out of their stable home orbits. It could be triggered by a nearby star passing by our system. It could be caused by our entire solar system travelling through a slightly denser pocket of gas inside the galaxy. Absolutely anything that delivers a tiny gravitational hit to a comet can cause it to lose its balance and fall inward towards our position. Our comet has officially been disturbed. Now the Sun's immense, dominant gravity completely takes over the situation. you can easily conceptualize the gravitational profile of our solar system as being exactly like a steep hillside. Parked all the way at the absolute bottom of that hill is our Sun, while the comets sit all the way at the very top of the slope. Once they are dislodged from the top, there is only one single physical direction for them to travel. They are forced to fall straight down the hill toward the Sun. Our comet accelerates rapidly as it dives towards the Sun, but its true path through the system is far from a simple straight line. Shifting gravity radiating from the major planets can easily throw comets completely off course, or launch them out of the solar system entirely. If they manage to navigate past these massive planetary obstacles, the comets continue their high-speed journey toward the Sun. At this point, they begin one of the absolute most remarkable environmental transformations known to modern science. It is exactly like a chrysalis, transforming into a beautiful butterfly. They rapidly evolve into the most spectacular visual things that the universe has to offer. As it crosses past the orbit of Jupiter, our comet begins to change fundamentally. As it starts to move faster and faster, closing the physical distance to the Sun, it begins to strongly feel the star's intense thermal heat, and that is precisely the moment when things start to get wild. At a distance of 500 million miles away from the Sun, the heat brings our dormant comet to life. The frozen chemical gases trapped inside the rock start to actively vaporize. Expanding geysers of ice crystals and dust rise rapidly from the dark surface. As the comet continues to approach the Sun and gets continuously warmer, more and more gas is violently released into space. The comet transforms into a fuzzy ball of light. There is still a solid rocky core buried deep inside there, but it is now completely surrounded by a massive puffing cloud of evaporated material. This expanding cloud of dust and gas forms a temporary atmosphere, which astronomers refer to as a coma, around the core of the comet, and this exact mechanism is what creates the comet's characteristically huge tail. The entire process is driven directly by the energy of the Sun, and the transformation is far from over. There is a physical phenomenon known as the solar wind. This is actually a massive non-stop wave composed of highly charged electrical particles originating directly from the Sun. This solar wind completely fills the entire volume of our solar system. As our comet moves deeper and deeper into the system, the solar wind becomes continuously stronger and more intense. Like a powerful cosmic hurricane, the solar wind aggressively blasts the loose gas molecules away from our comet and pushes them straight out into deep space. These blown back gases form a second, distinct giant tail. The solid core of the comet might measure only a few miles from side to side, and the fuzzy coma might span a few thousand or tens of thousands of miles across. But the massive tail that gets swept back as that loose material is blown away by the solar wind can easily stretch for millions or even tens of millions of miles across space. Our comet hurtles through the vacuum of space at a blistering 50,000 miles an hour. It is about to enter the absolute most violent and volatile phase of its entire journey. At a distance of 200 million miles away from the Sun, the hard water ice resting on the world begins to rapidly vaporize. The very ground beneath your feet would start to shift, crack, and quake violently. As the frozen material deep beneath the surface is literally thawing out, great big volcanic jets of carbon dioxide and water ice start to violently erupt into space. This would absolutely not be a very safe or good place for a human visitor to be standing. The dark surface cracks wide open. Trapped gases explode aggressively. High-speed debris fires off in every single direction at once. The raw thrust generated by these violent eruptions causes the entire comet to begin tumbling erratically through space. Every single gas jet that turns on behaves exactly like a little rocket engine strapped directly onto the side of the comet. Like a high-powered dragster accelerating down a racetrack, our comet explodes violently to life with incredible speed, irresistible kinetic energy, and a massive plume of trailing debris. Our comet transforms into an authentic cosmic hot rod, but extreme speed and volatile energy represent a highly dangerous mix. Our comet could easily blow itself completely apart into pieces at any given moment. The fuzzy gas cloud surrounding our comet has now expanded until it is physically larger than the planet Jupiter. Its sweeping tail stretches across space for a mind-boggling 100 million miles. An object that was originally assembled 4.5 billion years ago has successfully emerged from the dark shadows of the system. Every single arrival of a brand new comet functions exactly like a precious scientific gift delivered straight from the universe. We have never before observed this specific little piece of the solar system. It represents a tiny, pristine building block, an authentic baby picture of our cosmic origins. It is completely brand new to human eyes. This gives our species a unique chance to study the true origins of our solar system. And what we are learning from these investigations is a complete revelation. Comets are turning out to be far more hostile, volatile, and deeply alien environments than any of us had ever previously imagined. With our modern advanced telescopes, we can analyse comets in significantly more detail than ever before in human history. But to truly comprehend them at a fundamental level, we need to get up close and peer directly into the absolute heart of a comet, its solid nucleus. One of the ultimate holy grails of modern comet science is to really figure out exactly what is hidden inside a comet's nucleus. What does the actual surface look like? What is the precise chemical composition of the material? What are the physical characteristics of the rocks and the volatiles that rest on that active surface? The nucleus stands as the fundamental structural building block of the solar system that scientists desperately want to investigate. That is exactly where the deep mysteries are hiding. There have been more than a dozen distinct space missions launched toward comets over the course of the past 3 decades. Every single one of those missions has provided us with a major scientific revelation. We have learned a massive amount about their internal chemistry. We have learned about the intense physical interactions they experience with the Sun. We have gathered data regarding their physical surfaces, their jagged terrain, and how radically different they look even when you travel from one spot on a comet to another. We are discovering that these objects are authentic, independent worlds unto themselves. For generations, scientists assumed that comets were clean and white, resembling a pristine snowball. That old theory changed completely in the year 1986, when the Giotto space probe beamed back the very first close-up images of Halley's Comet. For the very first time in human history, we possessed a clear snapshot of the absolute centre of that legendary comet, an object that has entered human historical records on many famous occasions. Instead of a bright snowball, we found a cold, dark, dead world. We observed a rocky object shaped exactly like a giant peanut. Halley was absolutely no snowball. A thick, velvet layer of pitch-black dust completely covered its entire surface. There were deep pits, rolling hills, and the body of Halley measured a massive 9 miles long, which was far larger than any astronomer had anticipated. Scientists originally assumed that all comets were structurally identical to one another. They were completely wrong. In the year 2004, NASA's Stardust probe flew directly into the streaming tail of Comet Wild 2 and successfully captured thousands of tiny floating dust particles. When Stardust brought those precious samples back home to Earth, we realised that in absolute fact, every single comet is a completely unique object. Just like every major planet is radically different, it looks like every comet is entirely different as well. Each one has its own independent history to tell us. Completely different raw materials went into their initial formation. Different internal heat sources were injected into their deep interiors. Different chemical and geological processes occurred over time. Each one is a unique world waiting for us to explore it. Some comets are truly bizarre. Consider the real spacecraft images captured of Comet Hartley 2. This comet is so incredibly weird that it literally snows in space. It is completely strange. Our instruments were able to detect golf ball-sized chunks of solid dry ice that are actively following the comet around in a cloud stretching up to 1 million miles away from the central nucleus. This thing is just making a massive chemical mess in space. Hartley 2 is just amazing to look at. It looks exactly like you are standing inside the middle of a glass snow globe that someone shook up aggressively, with all these little chunks floating around out there like a swarm of flies buzzing around food. It just doesn't look right at all. Hartley 2 is a highly hyperactive comet. It tumbles much faster and spits out significantly more debris than most other comets of its physical size. Comets are completely alien worlds. When we look at Comet Tempel 1, we observe smooth plateaus, deep impact craters, and sheer cliffs that tower 60 feet high into space. Layers of rock lie directly on top of each other, resembling a massive stack of pancakes. Each comet seems to possess its own highly individualized history. And it was Tempel 1 that provided scientists with their absolute biggest breakthrough to date. In the year 2005, the Deep Impact Space Probe intentionally slammed a heavy projectile directly into its surface. Talk about a spectacular 4th of July celebration. I mean, can you possibly imagine anything better than that? We actually blew a massive hole directly into a comet moving through space. That has got to be one of the more amazing things that NASA has ever accomplished. The physical material that the impact violently ejected allowed humanity to see inside a comet's nucleus for the very first time in history. The findings were completely unexpected. We discovered things like rubies and peridot gemstones, tiny little precious crystals hidden inside the core of the comet. And we found all kinds of complex organic molecules, the exact variation of chemical structures that human beings are made of. Because of this data, scientists now believe that comets play an incredibly critical role across our universe. Where did the original ingredients of life come from? Where were they all mixed together in the early days? Where did all of Earth's liquid water originate? Comets could easily hold the definitive key to understanding the true nature of life itself. Opportunities for human beings to study these fascinating comets from an up-close perspective are incredibly rare in astronomy. At this very moment, our target comet is moving at an absolutely blistering rate of speed toward a destination in the solar system where no human-made spacecraft could ever hope to survive. The roaring furnace of our Sun, 4 billion long years ago, the dominant force of gravity violently hurled these comets completely out to the distant fringes of our local star system. Today, that exact same physical mechanism possesses the capability to drag them right back inward. As our comet cruises past the orbit of the Earth, it officially crosses into the absolute most violent and volatile phase of its entire spatial journey. It torpedoes directly toward the fiery surface of the Sun at a mind-boggling speed of 100,000 miles an hour. The outer surface of the comet is now intensely sizzling and crackling with aggressive physical activity. Blistering environmental temperatures are being created all across its dark terrain. Enormous explosive geysers composed of frozen ice crystals and vaporized gas are being forcefully shot high off the surface. Violent volcanic gas jets are erupting all over the place, across the entire landscape. The body is tumbling wildly in all directions. Its overall physical rotational state is shifting rapidly, and the very ground itself is essentially cracking up and breaking apart right underneath your feet. deep within the interior layers of the comet, compressed pockets of trapped gas explode aggressively and violently fling huge boulders straight out into the surrounding vacuum of space. Because of this non-stop eruption, the comet is rapidly losing its physical mass. It is systematically shrinking in size. As we drag closer and closer to the Sun, and more of the volatile chemical compounds are forced to evaporate off its surface, this intense material loss can actually change the entire rotational profile of the comet. It can cause the body to tumble out of control. It can even physically push the object along its orbital route, which means these eruptions can actually alter the spatial orbit of the comet itself. Comets possess the capability to shed up to 50 tons of solid ice and gas every single second they spend near the Sun. Enormous internal pressures build up continuously inside the boundaries of the nucleus. The core could easily become profoundly unstable. It could even completely break apart into scattered fragments at any given moment. As these comets finally reach their closest physical approach to the Sun, their ongoing existence hangs on an absolute knife edge. The reality of space is that many of them simply will not manage to survive this close encounter. Our instruments have been able to capture actual imagery of comets getting completely swallowed up by the Sun. You can watch them on our sensors as they pelt directly into the solar furnace, where the entire celestial body, whether it measures a mile across or 10 miles wide, gets completely, utterly and irreversibly destroyed. A specialized solar observatory successfully recorded these extraordinary and historic images. They clearly display small comets, known to astronomers as sun grazers, executing a suicidal dive directly towards the Sun. Here they are exposed to immense crushing gravitational forces and are instantly torched by the ferocious heat of the solar atmosphere. Many of them are completely vaporized into nothingness. Yet, even in the deep freeze of outer space, vast explosions can tear comets apart. In the year 2007, Comet Holmes was travelling along a path heading away from the Sun when something entirely extraordinary occurred. In less than a single day, the comet grew 500,000 times brighter to our instruments. The puffing cloud of gas surrounding it ballooned outward into space. It is actually relatively common for a coma, the fuzzy atmospheric part around a comet, to expand large enough to be bigger than the giant planet Jupiter, stretching 100,000 miles from side to side. But that expansion process normally takes long days, weeks and months to gradually build up. To witness a single massive event, something that happened boom all at once in a sudden catastrophe, create a shell around Comet Holmes that was physically larger than Jupiter is completely amazing to me. Humanity had never seen anything quite like this anywhere before in the history of science. In fact, the expanding coma of the comet briefly grew so immense that it was actually larger than the Sun itself. For a short period of time, it stood as the absolute largest single object in the entire solar system, a structural reality that was entirely unprecedented. Without any advanced warning, Comet Holmes simply blew apart in the dark. It stands as the largest cometary explosion ever officially recorded by our species. The resulting debris field stretched across space for 1,000,000 miles. Exactly what triggered this massive explosion is still highly unclear to scientists. One current theory suggests that perhaps Comet Holmes violently slammed into a stray asteroid of some sort, creating this gigantic megaflare out in space. Another distinct possibility is that perhaps the comet was structurally unstable internally, and an explosion caused by expanding trapped gases ripped the entire comet apart from the inside. At the present time, we simply do not know the definitive answer. The lives of all comets hang by a very thin thread. Our specific comet managed to survive its close encounter with the Sun, but it has paid a massive physical price. Its external geography has been totally and completely rearranged. Huge chunks of terrain, mountaintops worth of solid rock, have vanished entirely. An object which measured perhaps 10 or 20 miles across has lost hundreds or perhaps thousands of tons of rock and ice on its journey. As our comet leaves the Sun behind and travels out into the system, the activity on its surface quickly subsides. On its outward journey away from the heat, a comet gradually begins to shut down completely. It becomes cooler, less active, and more stable. The violent gas jets begin to turn off one by one. The fuzzy coma begins to blow away into the void, and you are left with nothing but a quiet little ball of ice and dirt. It returns to the freezing depths of outer space, becoming completely dormant once again. But our violent Sun is just one of many dangerous challenges that a comet must survive. Comets must also successfully navigate past the immense gravitational pull of the major planets. Our planet Earth's gravity is way too small to have any real effect on a passing comet. But Jupiter is a completely different story. It is a monumentally large planet. It possesses 300 times the physical mass of the Earth. If a comet passes within even a few million miles of Jupiter, that event can completely alter its orbit, and the consequences of that orbital shift can be absolutely catastrophic. In the year 1994, a comet named Shoemaker-Levy 9 flew a little bit too close to the giant planet Jupiter. Scientists watched in awe as the planet's immense gravitational tidal forces physically tore the comet apart into pieces. The broken remains then headed along a path straight toward Jupiter itself. Many people in the scientific community originally thought that the incoming impacts wouldn't do anything notable to Jupiter. They assumed that the gas giant would just sort of swallow the chunks up without even a burp. But that is not what happened at all. 21 distinct comet fragments smashed directly into Jupiter's thick atmosphere, one after another. Each individual impact released more raw energy than all of the world's nuclear arsenals combined into a single blast. Comet Shoemaker-Levy 9 was not a particularly massive comet when compared to other monsters, and it wasn't even a very dense object. It actually possessed the physical consistency of common cotton candy. A human being could have easily pulled bits of it apart with their bare fingers. Yet, this rather tenuous, fragile little icy creature managed to create unimaginable destruction across a giant planet. The impacts hurled massive plumes of superheated debris thousands of miles high into space, and permanently scarred Jupiter's atmosphere with dark, visible lesions. The historic event completely rocked the worldwide scientific community. To actually observe it happen for ourselves, to witness the immense destructive power unleashed by an object that is really not much bigger than an ordinary hill on Earth, was really pretty terrifying for astronomers. Even though we already knew the mathematics behind impacts, to see it happen with our own eyes was amazing. The Shoemaker-Levy 9 impact really woke astronomers up to the scary fact that major impacts can happen right now in the modern era, and they can happen right here in our neck of the woods. If a comet measuring just a few miles across were to ever strike our planet, the result would be completely catastrophic for human civilization. Massive tidal waves would devastate the land masses of the globe. High-speed debris would rain down from the sky everywhere at once, and life as we know it would instantly end. Yet, comet impacts can also behave as a highly creative force. They could have even triggered the original birth of life on our world. Across the wide universe, comets cause massive amounts of destruction. They can travel at speeds 50 or more times faster than a high-velocity rifle bullet. And you are talking about an object that is the size of an actual mountain. Therefore, the total amount of kinetic energy that this thing releases upon direct impact is completely devastating. But they are not always destructive forces. They possess another highly creative side, scientists currently believe they can systematically shape the environments of entire worlds. Consider Titan, which stands as the largest of Saturn's many moons. It is the single moon inside our entire solar system that possesses a thick atmosphere, and its surface is covered in flowing rivers and wide lakes composed of liquid methane. Titan was fundamentally transformed by comets. Radar images captured by our space probes reveal a moon that was completely shaped by a continuous blizzard of comets that rained down across its surface over the course of millions of years. Each individual comet completely vaporized when it struck the moon, releasing rich gases from deep inside its nucleus. Gradually, these trapped gases built up a rich organic atmosphere over time, and in this strange liquid landscape, comets successfully turned a barren space rock into a highly Earth-like world. Comets, in some sense, function as the ultimate environmental engineers of the solar system. Cometary impacts could have easily delivered the unique chemicals which generated the atmospheres not just of Titan, but even perhaps the early Earth itself. So, if comets possess the immense power to reshape entire worlds, what exact part did they play in the ancient history of our own home planet? To find out the definitive answer to that question, we need to get closer to a comet than we have ever managed to get before. We need to actually land a spacecraft on one. In March of the year 2004, the historic Rosetta mission was officially launched into space. The Rosetta mission was intentionally named after the famous Rosetta Stone, because just like that ancient stone gave human linguists the vital keys to finally deciphering an ancient dead language, we are hoping that this comet will provide scientists with the keys to truly understanding the ancient solar system. November 11th of the year 2014 will stand forever as a major landmark in the history of human space exploration. For the very first time, a human-made spacecraft will touch down directly on the active surface of a comet. All previous space missions sent to investigate comets were basically high-speed flybys, and they basically gave us nothing more than tantalizing evidence that there was a far greater mystery yet to be solved. Now we are going to actually land a vehicle on a comet. We are going to get up close and dirty with a live comet streaming through outer space, and this is completely unprecedented for our species. The Rosetta spacecraft is roughly around the physical size of a standard car, and it flies through space at 20,000 miles an hour. It is heading for a target comet that features a solid nucleus, measuring 3 miles wide, which orbits the Sun once every 6.5 years. A robotic lander will drop down to the surface, beginning the absolute most detailed study of a comet ever attempted in human history. It is going to look at what the surface looks like from the ground. It is going to take actual physical samples of the terrain. It is going to look at the geometry of the landscape. It is going to be able to actually probe deep inside the interior of the comet to see exactly what it is made of and how it is structurally put together. We are hopefully going to learn more from this single mission about one comet than we have known about all comets collectively for centuries. The Rosetta mission should answer some very simple fundamental questions for us. Is the comet porous? Is it structurally like a common sponge? Is it filled with a bunch of internal tubes? Is it shaped like a snowflake, featuring a delicate fairy castle structure? Answering these questions will directly help us understand exactly how heat flows within the body, and maybe teach us what causes certain portions of it to become a violent gas jet, while other portions remain quiet. But this is just the beginning of the project. For an entire continuous year, Rosetta will study the comet on its epic journey around the Sun, utilizing advanced technology that successfully mimics the 5 human senses. We have got instruments that can see. We have got a kind of an ultrasound experiment, and instruments that function as the exact equivalent of your hands. We would like to understand absolutely everything possible about this comet's journey around the Sun. from the moments when it is perfectly quiet to when it is at its most hyperactive state. But we have to successfully get there first. Just to reach the comet, scientists must overcome truly enormous technical challenges. Rosetta must hit a target that is just 3 miles wide, while travelling at a speed of 34,000 miles an hour. Landing on it will be even harder. Comets possess virtually zero gravity. There is not any notable force that is going to pull you down to the surface, and there is no atmosphere to speak of, so you cannot unfurl a parachute and just sail down until you touch down on the ground. You have to figure out a highly specialised way to get your lander to actually reside and rest on the surface without bouncing off. Technicians developed an ingenious solution to this problem. The lander is fully equipped with shock absorbers and a specialised harpoon system. When it makes initial contact with the surface, the harpoon will be instantly released down into the substrate, and it features prongs that will open up inside the rock to firmly prevent the lander from coming back up. Rosetta will attempt to solve some of science's absolute deepest mysteries. We would very much like to know why it is that Earth possesses liquid water, and so much of it compared to any other place that we have ever observed across space. How did the water get here? There is a major theory which states that comets delivered the water to the Earth long ago. But the real question is, can we actually prove it? To find out, the lander will collect water molecules to compare them with water found on Earth. But scientists hope to go even further than that. We are on the brink of making an extraordinary discovery. We may find proof that life itself has an extraterrestrial origin, and that it was brought to Earth by comets. Living organisms have successfully managed to survive and flourish on our home planet for a massive stretch of history, lasting at least 3.5 billion years. But despite this incredibly long duration of biological history, human science still does not fully comprehend or agree on the true, definitive beginnings of life. For a very long time, scientists worked under the assumption that life originally generated entirely on Earth itself. The old conventional model suggested that primitive volcanic gases combined with heavy water vapour to gradually form our early oceans and a stabilising atmosphere. After those components settled, massive storms filled with crackling lightning added the vital creative electrical spark necessary for early cellular life to finally begin. Now, modern advanced research indicates that this historical assumption is completely wrong, and the definitive proof is waiting for us out in open space. In the year 1997, a colossal object known as Comet Hale-Bopp appeared in our night skies. It stood as one of the single largest and most brilliantly shining comets ever recorded in human history. When astronomers trained their spectrometers on it, they discovered that the comet was intensely packed with vast quantities of water ice, various chemical gases, and carbon materials. These represent the absolute foundational ingredients required for the generation of life. That incredible discovery raised profound, mind-boggling questions for our species. We are all thoroughly used to the comfortable idea that living things originated right here on the surface of the Earth, and that is probably still true for highly complex multicellular life forms. But where did the original chemical building blocks come from in the first place? Where did the water that populates our bodies and the complex organic molecules that make up the very essence of living structures originally come from? The truth is, they actually may not have been an intrinsic, natural part of the Earth to begin with. They likely came from somewhere else entirely out in the dark. The data from Hale-Bopp strongly suggested that the raw structural materials for life might possess an extraterrestrial origin. Since that historic sighting, scientists have successfully uncovered even more definitive evidence. A prominent astrobiologist named Dante Lauretta made an amazing discovery when he found that the captured dust streaming from Comet Wild 2 contained highly specific minerals that can only physically form in environments featuring intense heat and liquid water. We detected sulfide minerals inside the samples. We located iron oxides. We even found carbonate minerals, which represent the exact same variation of structural materials that marine organisms on Earth use to build their protective shells. This finding was completely unlike anything scientists previously thought was possible to form in the freezing outer regions of the early solar system. Furthermore, laboratory analysis revealed that Comet Wild 2 contains actual amino acids. That discovery is incredibly exciting for science because amino acids function as the absolute building blocks of proteins, and proteins are completely essential biomolecules for every single life form existing on Earth. These incredible space discoveries have fundamentally transformed our old understanding of comets. Many modern scientists now firmly believe that they are significantly more than just simple frozen time capsules drifting in the dark. Perhaps they play an absolutely central active role in the physical history of our planet. We have successfully learned from the close study of a single comet and the physical results returned by the Stardust mission that these objects are highly complex chemical laboratories where the organic ingredients of life can easily form. These materials highly likely did not arise naturally on the surface of the Earth, from standard geological processes occurring on our planet. Instead, they had to be systematically delivered to us by these icy messengers travelling all the way from the outer solar system. The wild idea that we may owe our entire biological existence to ancient comet impacts is completely astounding, but not every single person in the scientific community is fully convinced just yet. There is admittedly very good circumstantial evidence indicating that a comet might have been critically important to the development of life, but we do not really have the definitive smoking gun yet. If we are acting as a team of specialised comet science investigators trying to prove this case in a cosmic court of law, we simply haven't got all the hard proof perfectly lined up yet. It remains quite possible that what we are observing out there on those icy bodies has absolutely nothing to do with life as we currently know it on Earth. Scientists are hoping that the ongoing Rosetta mission will finally resolve this great debate once and for all. If we can establish a direct, undeniable correlation between the amino acids found on comets and the specific amino acids we possess inside living organisms on Earth, that finding will stand as one of the most significant discoveries in the entire history of science. The grand story of life on Earth originally began 4.5 billion years ago. When our planet first formed out of the cosmic dust, it existed as a completely barren, dry and intensely hostile wasteland. Then, 700 million years later, the entire solar system plunged into a state of severe gravitational turmoil and chaos. Shifting gravity violently ripped trillions of comets completely out of their stable outer orbits and hurled them in all directions, sending many of them screaming straight into the inner solar system. They rained down in a continuous, non-stop bombardment on the early Earth for 300 million straight years. As they smashed into the hot terrain, they rapidly released their trapped internal gases and rich organic materials, successfully creating our planetary atmosphere and pooling into the vast oceans. Finally, after the dust settled, life could begin. It is an incredibly dramatic and beautiful story, but is it actually true? Only time will tell as we continue to study these mysterious icy objects, whether or not we can really pin down the exact physical mechanisms and find out precisely how it all got started. In 100 years, hopefully, people will look back at our era and say, wouldn't it be cool to have been alive at that time, to be a first-hand witness and be among the very first humans to make these incredible discoveries. In the meantime, our grand search for definitive proof continues moving forward. I cannot say with absolute certainty if comets brought all of these raw ingredients to the Earth and that we directly evolved from those materials. The sky is completely full of stars, massive galaxies, orbiting planets, and wandering asteroids. The actual descriptive word asteroid literally means star-like. Even when you observe them using the very best visual telescopes on Earth, they look like nothing more than simple, tiny points of sharp light in the night sky. But in reality, they are massive cosmic boulders, and there are trillions of them scattered across our solar system. They range in size from a small car to gargantuan rock giants that stretch hundreds of miles across. Together, they tell the incredible story of how we originally came to be. The planet Earth was physically made by asteroids 4.5 billion years ago. During this early era, the solar system existed as a vast cosmic whirlpool of gas and dust. Microscopic dust particles constantly collided and stuck together to gradually create asteroids. In our own solar system, and in fact in every solar system across the universe, the very first objects to form, the first large solid rocks before major planets ever exist, are essentially asteroids. At this point in cosmic history, there are absolutely no planets existing yet. Instead, trillions of individual rocks and stones swirl aggressively around the newly born sun. It would have been a very strange and chaotic place to navigate, resembling a giant, high-speed merry-go-round of all these jagged objects orbiting around the central sun, and there are millions of these ancient asteroids travelling in different sizes and different bizarre shapes. These ancient asteroids will systematically shape the entire future of the solar system and build the solid planet that we live on today. Asteroids are so much more than just simple dead rocks floating in space. They are the actual primary building blocks of our very own planet. Billions of small asteroids must continuously clump together to make a whole planet. But asteroids move through space at speeds of thousands of miles an hour. Getting them to stick together during a high-speed collision instead of blowing each other apart is incredibly hard. We can look at a high-speed stock car race to help visualize what the early solar system may have actually looked like. High-speed car collisions cause massive structural damage. Parts smash off violently and scatter everywhere. Asteroid collisions are exactly the same. To successfully join together into a larger body, they must somehow collide and stick. Stock cars show us exactly how this process can happen. They are moving incredibly fast, but they are all travelling in the exact same direction around the track, which matches the behaviour of the asteroids orbiting in the early solar system. Because they are moving in the same direction, when collisions do happen, they are relatively gentle side swipes. Instead of smashing each other to pieces, they merge and join together. These are planets in the very early stages of making. They are going around the Sun at almost the exact same relative speed, and they begin to stick together, and that is precisely how rocky planets begin to form. Asteroids gather into massive rock piles, moving exactly like two crash cars locked together on a track. As more and more surrounding asteroids collide with the pile, the rock piles grow continuously larger. Attempting to build an entire major planet this way, by random clumping, would normally take billions of years. Yet, history shows the planets formed in just a few million short years. How did the universe accelerate this process? When the growing rock piles finally reach the physical size of a mountain, the force of gravity completely changes the game and speeds up the entire construction process. Gravity started to become critically important when the objects grew to about the size of a massive mountain. It was when they reached several miles across that they finally accumulated enough physical mass for their internal gravity to start actively drawing surrounding material in toward them. If the Earth weren't here right now and it were just a lone mountain several miles across, floating in space, and I was placed a few miles away, I would very slowly start to drift toward it, moving faster and faster as I closed the distance, accelerating the entire way until I actually impacted the surface. The mountain's gravity would draw me in, pulling on me until I struck the mountain itself. Large asteroids are essentially mountains in space. The early solar system was completely packed with them. Their growing gravity pulls other nearby asteroids toward them. The larger an asteroid becomes, the more surrounding rocks it successfully pulls in, and the faster it grows. At that point, the events happened very quickly. It would actively draw that material in and grow very rapidly. One of these early space mountains keeps on growing and growing until there are absolutely no stray rocks left in its orbital path to pull in. At that point, it is no longer classified as a simple asteroid. It has officially become a young planet. The planet Earth and all of the other rocky planets owe their ongoing physical existence to the fact that there were trillions of asteroids back then. This is exactly how all rocky planets form across the universe. Asteroids join together until there are absolutely none left in the vicinity. Mercury, Venus, Earth and Mars are all essentially overgrown asteroids. But beyond the orbit of Mars, something went completely wrong with this construction process. There are no major rocky planets to be found there. Instead, we observe billions of stray rocks and boulders that never managed to join together. This is the asteroid belt. Out here, planetary construction came to a sudden halt before a rocky planet could form, all because of the presence of Jupiter. The massive gas giant had already successfully formed nearby. Jupiter is absolutely humongous. It is the definitive 800-pound gorilla of our solar system. It completely dominates everything around it gravitationally. 4.5 billion years ago, Jupiter's massive gravity caused complete havoc in this region. It violently flung asteroids in every direction, knocking giant boulders from their regular orbits onto extreme chaotic paths. The orderly stock car race came to an end, and a violent demolition derby began. Once Jupiter got involved, the solar system began to look like a demolition derby, with things colliding with each other and going in all sorts of different directions. It was a cosmic pileup. Rocks smashed into each other from every direction in violent, chaotic collisions. These rocks don't clump together gently anymore. They shatter each other apart into fragments and create the asteroid belt. Violent collisions still actively rock the asteroid belt today. In the year 2010, the Hubble Space Telescope captured clear evidence of this ongoing violence when it photographed the aftermath of a hypervelocity collision between two asteroids. Asteroids can both create and destroy. If many of them come together gently, you get planets. Too much violence, and you get the asteroid belt, a giant graveyard for a planet that never managed to form. The asteroid belt remains a mysterious realm full of extreme danger and immense promise. It is a brand new frontier just waiting to be explored. Asteroids are just as diverse as planets or moons. Some are metallic, some are rocky, and some are icy. Some even feature their own tiny moons orbiting around them. They come in all shapes and sizes, ranging from small boulders all the way to miniature worlds. And they are everywhere across the universe. Distant solar systems possess their own asteroid belts. The star Epsilon Eridani is just 10 light-years away, and it features not one, but two distinct asteroid belts. Another distant star has a belt 25 times larger than our own. If you were living on a planet in that system, the asteroid belt would look much brighter than the Milky Way, appearing as a massive streak of light across the night sky. Asteroid belts are the scraps left over after planets have formed, so they tell us a lot about their solar systems. Our asteroid belt is full of variety, containing millions of strange asteroids, each with a unique story to tell, yet humanity has barely explored it at all. That is about to change. The first dedicated mission to the asteroid belt is underway, the Dawn probe. Its goal is to explore a mysterious, distant realm. We are going to learn more about the main belt asteroids from this one mission, than we have since we discovered the asteroid belt in the first place. In July of 2011, Dawn arrived at its first target and sent back these pictures. Vesta is the second largest asteroid in the belt. It almost became a planet. Then Jupiter's massive gravity stunted its growth. Today it stands as a miniature world. One of the common misconceptions about the asteroid belt is that things are fairly small, but some of the largest asteroids are really more correctly thought of as minor planets. They are several hundred miles across. Vesta even features a massive mountain that is 3 times higher than Mount Everest. It's a real excitement because you're seeing a new world for the first time, and you know just enough to be dangerous in trying to explain what it is that you're seeing. Vesta is like a snapshot of the infant Earth when our planet was just as wide as Arizona. We're seeing perhaps what an embryonic, early terrestrial planet like Earth looked like in the first few million years of its history. The Dawn probe has already found that Vesta possesses a solid iron core like the Earth, clear evidence that the Earth's core formed when the planet was still very young. This stunted world offers us a clear window into the Earth's distant past. We're seeing things that we didn't necessarily expect, but that's what makes it fun. After Vesta, the Dawn mission will head into the outer reaches of the asteroid belt to explore an icy primeval world 4 times bigger than Vesta. There, Dawn aims to settle another mystery about the Earth's past. Where did our oceans come from? The asteroid belt is ancient, violent and remote, sitting hundreds of millions of miles from Earth. But not all asteroids stay inside the asteroid belt. They can roam all over the solar system. The Moon's surface records a violent past, a massive cosmic bombardment. We see evidence of this every single night when the Moon comes out. What do we see? A pockmarked, barren world. This is clear evidence that there was an intense rain of asteroids and debris coming from outer space, completely disfiguring the surface of the Moon. Millions of craters cover the Moon, including the largest in the solar system, measuring 1,500 miles across, which is itself scarred by thousands of smaller craters. A storm of asteroids blasted the Moon 4 billion years ago, and if that happened to the Moon, it must also have happened to Earth. The Earth is a much bigger, more massive target in space. For every one of those craters you see on the Moon, you've got to imagine 50 or 60 craters here on the planet Earth. The impacts back then must have been horrendous. Every few weeks, a gigantic object hurled from outer space, gouging out a huge chunk of the planet Earth. We call it the Late Heavy Bombardment. For 200 million years, fireballs rained from the sky. The impacts triggered earthquakes bigger than any in recorded history. 10,000 mile-an-hour hurricanes ripped through Earth's primitive atmosphere. But asteroids also brought a new substance to Earth. Some asteroids contain ice, frozen water that melts on impact. Each asteroid brings a little more water. But could asteroids really bring enough water to cover 2/3 of our planet? One of the questions we have is, how did water get to the Earth? Because the original Earth, we think, was very hot and very dry. NASA's Dawn probe aims to find out. The ancient asteroid belt continues to hold vast quantities of icy celestial material to this very day, locked away in its coldest, absolute, most distant outer regions. In the year 2015, NASA's Dawn probe will officially arrive at the solar system's absolute largest single asteroid, which is known to astronomers as Ceres. Ceres is so monumentally massive that it actually contains 1/3 of the total cumulative mass of the entire asteroid belt combined, rendering it 4 times larger than any other known asteroid in the local neighbourhood. A massive amount of this giant body looks to our instruments like pure, unblemished ice. Ceres possesses a highly dense, rocky interior that is completely wrapped inside a sprawling, ice-rich mantle layer. Because it sits far enough away from the heat of the central sun, the surrounding environment is cold enough that the frozen material remains completely stable over billions of years. Ceres measures just about 600 miles across from side to side. Yet, despite its relatively small planetary size, there may actually be far more frozen water trapped here than all of the combined fresh liquid water flowing on the planet Earth. The ongoing Dawn mission will systematically find out the definitive answer for sure. If Ceres really does turn out to hold such a staggering volume of water ice, it could easily help scientists explain the ancient mystery of why the Earth possesses so much liquid water today. When a chaotic storm of asteroids aggressively bombarded the early Earth 4 billion years ago, massive icy bodies resembling Ceres could have easily delivered these vast amounts of water to our world. Water itself, travelling in the frozen form of space ice, came crashing down from the heavens to successfully create the lush, deep oceans of the Earth. And it is not just our sprawling oceans that may have originated from space. The atmospheric clouds, the flowing rivers, and the giant continental glaciers may all have originally come from deep space. The Dawn mission may simultaneously uncover something even more profoundly significant resting on the surface of Ceres. It may find a massive hidden ocean resting directly underneath the outer shell of ice. This would exist as an inner mantle composed entirely of liquid water, melted continuously over time by geothermal heat radiating outward from the dwarf planet's solid core. Life as we currently know it entirely depends on the presence of liquid water to survive. Wherever we manage to locate liquid water in the universe, we may simultaneously find the vital spark of living organisms. If there is an active liquid water ocean sloshing underneath the frozen surface today, that reality immediately begs the profound question of whether or not basic life forms could be thriving down there in the dark. Extraterrestrial life could have easily started its evolutionary journey right in the middle of the asteroid belt. Ceres could easily be home to basic life forms flourishing continuously inside a hidden subsurface ocean. If asteroids like Ceres possess the capability to actively support life, that finding could finally reveal exactly how life originally got started on the Earth. 4 billion years ago, a relentless barrage of asteroids bombarded the young, vulnerable Earth. They delivered water, and they may have simultaneously brought life from the asteroid belt straight into Earth's newborn oceans. These would be primitive, single-celled organisms that successfully thrived in the warm water and ultimately evolved over eons into all of the Earth's modern living creatures. This process transformed a dead rock into a vibrant planet that completely brims with diverse life forms. Our absolute earliest biological ancestors may have originally arrived on our world from the asteroid belt. Perhaps these little space worlds could be the primary incubators of life throughout our entire solar system, and maybe even inside other alien solar systems surrounding distant stars across the galaxy. Asteroids may actively bring the seeds of life to vacant worlds throughout the wider universe. But at the exact same time, they can also bring absolute death and destruction. Asteroids are completely crucial to the cycle of life in the universe, but once life successfully gets started on a planet, asteroids can also completely end it. Asteroids really possess two radically opposing sides to them. They represent creation and absolute destruction, all wrapped up together into a single rocky body. The planet Earth sits right in the direct firing line of these objects. We have come to fully realise in recent years that human beings live in a kind of a chaotic cosmic shooting gallery. Astronauts have witnessed this terrifying reality firsthand during space missions. When I flew on the Apollo 9 mission and I conducted an extravehicular activity outside the spacecraft, it is very likely that I was physically hit by a very, very small asteroid fragment. And you know, an object like that will easily make a hole right through a standard spacesuit if you are not careful. The vast majority of cosmic objects floating in the immediate vicinity of the Earth are tiny, but they move through the vacuum at speeds of thousands of miles per hour. Therefore, the suits are very, very well built and structurally reinforced. The structural result of that reinforcing is that they are incredibly heavy, but we have fortunately never had a single suit penetrated by an object yet. The Earth too possesses its own built-in protective shield against smaller asteroids, our thick atmosphere. When small asteroids strike the outer layers of the atmosphere at high speeds, the friction causes them to instantly burn up. I can distinctly remember one night during a spaceflight when we were looking down at the dark, unilluminated side of the Earth, and I kept thinking that I saw an occasional bright flash of light down below, but I wasn't entirely sure. And then we suddenly realised, of course, we are looking at shooting stars from above. Most ordinary people don't fully realise that on any given clear night, if you simply lie down in the grass and stare up at the night sky, you will see shooting stars flashing by, many of them each hour. The vast majority of these shooting stars are only about the physical size of a single grain of sand. These tiny grains burn up completely in the air, but larger space rocks possess the capability to punch right through the atmosphere to strike the ground. We have clear, undeniable proof of this happening, resting in the desert meteor crater in Arizona. This massive bowl was gouged out of the Earth by an incoming asteroid that measured just 150 feet across. You can easily visualize the huge force that excavated this landscape, and you can also clearly see the flipped layers of material that were turned completely over as the crater was excavated. And so some of the large rocks resting around this region are actually sitting completely upside down from where they originally started before the blast. There have been millions of major impacts exactly like this in Earth's long past, and there will inevitably be more in our future. Imagine a major modern city sitting exactly where Meteor Crater is located right now. The citizens would suddenly see a massive fireball screaming through the sky very quickly. This incoming object is moving at a speed of 8 miles a second, and so it wouldn't take very long for it to move all the way across the horizon and strike the ground. Intense heat radiating from the fireball instantly scorches the surface of the land, but the vast majority of the structural damage occurs right after the actual impact takes place. Once it strikes the solid ground, the full crater takes only a few brief seconds to create. So you are dealing with a very short amount of time, a very large amount of raw kinetic energy, and very devastating global effects. The asteroid itself is completely obliterated by the blast. A mighty shockwave generates surface winds that are 6 times more powerful than the most intense hurricane on Earth. You have a violent blast that comes tearing out for several miles, accompanied by large falling debris that would easily crush modern buildings and homes. If a rock of that exact scale hit our world today, the asteroid from Meteor Crater would be a definitive city killer, but the Meteor Crater asteroid was actually tiny compared to other monsters. It was likely nothing more than a small fragment broken off from a much larger asteroid. Whatever it is that hit inside Meteor Crater wasn't very big at all. It was probably only about 50 yards across, meaning it wasn't even as large as a standard football field. There are millions of much larger asteroids wandering through the darkness of space. These larger bodies would cause even more terrifying carnage across the globe, functioning as country killers or worse. Asteroids that measure over a half-mile wide possess the power to completely end human civilization as we know it. They are global, worldwide killers. We know this for a fact because it has already happened before in Earth's history, and there are traces left behind everywhere. There is clear evidence of giant impacts scattered all over the world, and the proof is sitting right underneath your feet. And in fact, in some specific geographic locations, it is pretty easy to spot with the naked eye, like right here in southern Colorado. This specific layer of light-coloured rock represents the famous KT boundary. It is called a boundary because it marks the definitive transition point between two completely different geological time periods. Every single rock layer that was put down underneath the KT boundary contains dinosaur fossils inside it. Everything sitting above it contains absolutely zero dinosaurs. So it really marks that exact point in cosmic time when the dinosaurs completely went away. The light-coloured layer is highly rich in a chemical element called iridium. Iridium is incredibly rare on the surface of the Earth, but it is highly common inside space asteroids. So if a giant asteroid came screaming in, smacked directly into the Earth, and blew out a massive global dust cloud everywhere, the iridium inside the asteroid would have gradually settled down into a uniform layer all over the Earth. And that is exactly what we see resting right here in the rock. It serves as the clear fingerprint of a giant asteroid impact. There must have been some perfect peaceful morning millions of years ago before the asteroid impact, when the land of the dinosaurs was still very much as it had been for millions of continuous years. Then something strange would be sighted way up in the daytime sky, something incredibly bright and burning very hot. The incoming asteroid is 6 miles long, rendering it big enough to completely devastate the entire planet. The asteroid that came in and successfully formed this rock layer was incredibly massive and was moving very fast. And so when it impacted the Earth, all of that kinetic energy was instantly turned into a very, very big boom. It struck with the raw force of 5 billion Hiroshima nuclear bombs detonating at once. Large pieces of the Earth were blown directly out into space and then rained back down across the atmosphere. This created a global storm of falling fireballs. Wildfires raged continuously across the entire globe. Inside the KT boundary layer, you can find a prominent layer of soot, and that is a clear indication that there were global forest fires breaking out everywhere, meaning everything on Earth was basically on fire after this happened. The Earth plunged into absolute darkness as an impact winter took over, triggering a mass extinction. Basically, you can think of this event as every single environmental catastrophe you can imagine all happening at the exact same time. It was an incredibly bad day for planet Earth. It stands as a chilling reminder of the ongoing threat coming from space. Asteroids this big will inevitably hit us again. We will go the exact same way as the dinosaurs. We will be survived most likely by the bugs, the cockroaches. They will be the ones who will inherit this Earth, but hopefully that is going to be a long time from now. Is mankind doomed to vanish, or can we successfully dodge our fate? Asteroids built our world. They delivered our water. They killed off the dinosaurs and made room for new species to evolve. But asteroids are also a constant threat to our survival. We know absolutely for certain that there will be large impacts in the future, so it's not a question of if it will happen, it's only a question of when. Large meteor impacts happen roughly once every 60 to 100 million years. We are due for one soon perhaps. If we want to survive as a species, we need to prepare. We must actively find the asteroids, determine if they are heading for Earth, and then find a way to stop them. That's not easy, but it may be possible. Happily, there's a major difference between us and the dinosaurs. We have telescopes, and we can get advanced notice of an incoming impact. Asteroids are much smaller than stars and planets, making it incredibly hard to see them coming in the dark. To successfully track asteroids, you need a giant telescope, like the Arecibo Observatory in Puerto Rico. Right now, I'm standing on top of the largest telescope in the world, and this place may actually be our best defense against getting hit by one of these near-Earth asteroids. The vast bowl measures 1,000 feet across, and it's not only the world's biggest telescope, it's also the world's biggest radar dish. When you think about using standard radar to keep track of all the airplanes that are flying up in the sky? Well, this one is so immensely powerful it can actually track near-Earth objects millions of miles away in deep space. Unlike a normal telescope, radar can directly measure an object's exact distance and reveal precisely where it is located. That's perfect for tracking asteroids. In the year 2004, astronomers spotted a stadium-sized asteroid heading toward Earth. Its name is Apophis, after the Egyptian god of destruction. The day it might hit us, April 13th, 2029, Friday the 13th. Apophis was the first near-Earth object of the modern era that had astronomers honestly scared. There seemed to be a terrifying 1 in 30 chance of something catastrophic happening to our world. Arecibo sprang into action against the biggest threat from space ever detected. Apophis could devastate entire countries, but the asteroid's path was still highly uncertain. It might hit or it might just miss. Only Arecibo could tell us for sure. The Arecibo telescope was able to reduce the uncertainty of Apophis's path by 98%. It told us that there was no chance this thing would hit us in 2029. It will be close. Apophis will pass closer to the Earth than the Moon. It will cruise closer even than some of our communication satellites. We have powerful tools to detect asteroids. Someday we'll find one that will hit the Earth. How can we protect ourselves? The obvious strategy is to destroy the asteroid before it destroys us. But that could be risky. You don't want to blow it up because you may end up breaking it into 2 or 3 or 5 pieces, which then end up hitting all around the Earth and wiping out many more people. Exploding an asteroid could cause more harm than good. Better to make it miss completely. When an asteroid is headed for Earth, their future paths cross, and they'll both reach that crossing point at the same time. Imagine the Earth is a freight train and the asteroid is a car, both heading for a railroad crossing. If they reach that crossing at the same time, they will collide. The best way to avoid the impact is not to swerve away from the train. It's to hit the gas or the brakes. If you can cross the tracks before the train gets there, or wait for the train to pass and then cross them, that's what we want to do with asteroids, just to make sure that the asteroid and the Earth aren't at the same place at the same time. By simply slowing down the car, we're going to miss. That's the way to avert a collision. But asteroids don't come with brakes. We need another way to change their speed. One approach is to use the asteroid's gravity. For a small enough asteroid, all you need to do is park a large spacecraft right next to the asteroid. A spaceship would hover above the asteroid's surface. You can thrust with your spacecraft to keep it from falling onto the surface of the asteroid. And so it's like a little gravity tractor, using gravity as the tow line to move the asteroid out of the way. Over time, the gravity between them would slow down the asteroid just enough for it to miss the Earth completely. Asteroids could shape our future in another way. We could turn them from a deadly threat into a precious resource. Asteroids are a creative force. They build planets. They bring water. But they're also destructive. Asteroids are both a boon and a threat. Early on, they bring the materials for life. Later on, they can destroy life. Asteroids bring violence and death. But life may not always be in danger. Ultimately, if life becomes intelligent enough, it could send objects out to deflect or destroy the impending asteroids. We now have the technology to divert asteroids. That means we can treat them not as a threat, but as an opportunity. We could mine them. Many of them are just ripe for the taking in terms of wonderful mineral resources. And so the asteroids, in some ways, are literally gold mines in the sky. They're not just gold mines, they're zinc mines, aluminum mines, and platinum mines. Just one average-sized asteroid could contain minerals worth thousands of billions of dollars. But first, we have to reach the asteroids. On April 15th, 2010, President Obama announced a new plan. By 2025, we expect new spacecraft designed for long journeys to allow us to begin the first ever crewed missions beyond the Moon into deep space. We'll start by sending astronauts to an asteroid for the first time in history. Ironically, the easiest asteroids to reach are the same ones that threaten the Earth. As they pass by, a spaceship could rendezvous with the asteroid. Yet, even when asteroids come so close, asteroid mining may be too good to be true. The reason why we're not mining the asteroid belt today and letting the space program pay for itself is because of cost. It takes an enormous amount of rocket fuel and expertise to bring back an asteroid from out of space. But perhaps we don't need to bring the minerals back to Earth. We could use the resources of asteroids to build settlements out in space. You don't have to build a space station, it's already there. You don't need shielding because you can simply drill right into the soil and use the rocky material as shielding against radiation and micrometeorites. So in some sense, think of an asteroid as a ready-made space station. Low gravity makes it easy to come and go. There's plenty of water and all the construction materials that colonizers could ever need. So one day, when we have colonies in the asteroid belt and we need to build cities there, that's where we're going to find valuable deposits of metals in the asteroid belt itself. A vast band of cities in space, strung across 1 billion miles. And not just cities, but factories to turn metal from the asteroids into spaceships. Perhaps asteroids could actually provide the metal, the real structure to build our spacecraft. So somewhere up there between Mars and Jupiter, there may be the makings of our future spaceships. Ultimately, asteroids may be a stepping stone by which we can one day leave the entire solar system. Asteroids made the Earth. Perhaps they even brought life here, and in the future, asteroids could help humans escape the Earth and colonize the galaxy. So in a way, asteroids are drawing us out into space, whether to protect ourselves or to expand where we live. Advanced civilizations all over the universe may use asteroids as stepping stones to the stars. Mankind may soon enter the age of asteroids.